Hello everyone and welcome to this exciting new course from the Microsoft Cybersecurity Professional track called Windows 10 Security Features. This is the sixth course from the track and I will also be your instructor for this course, so let me properly introduce myself. My name is Christian Kalinescu, and I've been working for more than 10 years in IT and mainly as a senior infrastructure engineer. And now I currently run a cybersecurity operations center for a big company in the UK. I've helped many customers throughout my career to implement new technologies, to migrate from old technologies to new technologies, and I've consulted several customers as well on implementing security frameworks, security tools, and security services, being that they were on premises or in the cloud. I am certified by Microsoft on several desktop and server technologies, like Microsoft Certified Expert on Cloud Platform and Infrastructure, or Certified Azure Solutions Architect for the cloud technologies. In the field of cybersecurity, I am certified as a Microsoft Certified Cybersecurity Professional, CompTIA Security Plus Certified, and a Certified Ethical Hacker. So please join me in the second lesson of this introductory section, in which we are going to discuss about the course, about how it's structured, and several other interesting aspects. I'll see you in the next lesson. Hello everyone and welcome back to this course from the Microsoft Cybersecurity Professional track called Windows 10 Security Feature. We are in the second lesson of the introductory section, in which we are going to discuss about the course, about how it is structured, and much more. First of all, I want to let you know that this is the sixth course from a series of 9 courses which are meant to prepare you become a Microsoft cybersecurity professional. Basically, you will, after completing all the courses, you will be comfortable in implementing, configuring, and supporting the Microsoft security services. So please take a moment and take a look at this slide, which basically shows all the courses from the track and a few words about each course. So that being said, let's first of all establish who should be the audience for this course. Well, the audience for this course should be any cybersecurity enthusiast who wants to learn all about Microsoft security services. And of course, you don't need to go through the entire track. Maybe you are just interested in PowerShell security, for example, or maybe you're just interested in the security services offered by Microsoft Azure, or maybe you're just interested in the security features and services offered by the Windows 10 or Windows Server operating system. So you can take any of the courses, or you can take all the courses and complete the Microsoft Cybersecurity Professional track. Now, let's talk about the prerequisites necessary in order to attend the course. So, first of all, you would need to have a basic understanding of the Windows 10 operating system, of the Windows operating system more widely, let's say. You would need basic understanding of computer networks and basic knowledge of accessing and using simple Windows PowerShell commands. And when I say basic, I literally mean basic. Now, for the course overview, let's take a look and see how the course is structured and what you will be learning in this particular course. So, the course is structured in sections, and the first section is the introduction section. The first lesson, I have introduced myself. This is the second lesson in which we are going to discuss about the course. And you also have a third lesson here in the introductory section called How to Set Up the Lab Environment, because we'll talk about this in a few moments. You will have some labs available, some hands-on labs available at the end of the course, in which you'll get to experience hands-on, you'll get to practice in implementing and configuring some of the features that we'll be discussing throughout the course. Then we'll get into the second section of the course called Built-in Windows 10 Defenses, in which we are going to have just one lesson in which we are going to talk about the evolution of attacks. We are going to talk about the Windows 10 security stack and much more. Then in the third section, we are going to discuss how Windows 10 uses modern hardware features for security. And here we are going to talk, as the title suggests, about the hardware security features of Windows 10. We're going to get into secure boot. We're going to talk about secure boot and trusted boot, and of course, additional hardware security embedded in Windows 10. Then in the fourth section, we are going to discuss about Windows 10 software security features, and given the fact that there are so many security features embedded, software security features embedded in Windows 10, I have broken this up in two separate sections, as you can see, part 1 and part 2. So in the fourth section, we are going to discuss about Windows Defender Firewall and Virtual Secure Mode. We're going to get into Credential Guard and BitLocker, and of course the Windows Defender Antivirus and Windows Information Protection. Sorry. Then, in the fifth section, right, part 2 of Windows 10 software security features, we are going to discuss about Windows Defender Remote Credential Guard, about Device Guard, App Locker with Device Guard, and Windows Defender Smart Screen, and of course, we are going to also get into an overview of Windows 10 telemetry. Then in the last section here in the course, we are going to discuss about newly added security features since the creators update, and those are Windows Hello for Business. We're going to discuss about other security features and capabilities, and in the last lesson of the course, we are going to go through a ransomware case study. So that being said, guys, this is how the course is structured. This is the flow, let's say, of the course. And now let's see what would be the expected learning. So what will you learn in this course? After completing the course, what will you gain? What knowledge will you gain? What will you walk away with, let's say? So, first of all, I want to let you know that the course includes a mix of videos with some demonstration where applicable. You will have section review questions. So basically, at the end of each section, you will have review questions in the form of a quiz to basically test your knowledge on the topics learned in that particular section. You will have a final exam at the end of the course, and that is again in the form of a quiz, of a practice test with 20 questions which will test, of course, your knowledge on the topics learned throughout the entire course. And after that, you will have hands-on lab available. Actually, in this particular course, you will have 5 labs available in which you will get to practice hands-on at your own pace with some of the let's say security features and capabilities that you've learned throughout the course. Now, after completing the course, you will be able to understand the current nature of the security threat landscape. You will be able to explain the built-in security defenses of Windows 10 operating system. You will know about Windows 10 mitigations that you can configure. You will also learn about the Windows 10 mitigations that require no configuration, so that they're just there out of the box as soon as you install the operating system. And you will be able to describe some of the external tools that enhance the endpoint security. So this is the expected learning. This is what you'll get after completing the course. Again, I've talked about the final exam review questions and the hands-on labs. The final exam review questions are basically a set of 20 questions which are meant to test your knowledge on the topics learned throughout the entire course. And as I've mentioned, you will have 5 hands-on labs available at the end of the course to basically very cool lab. You'll get to experience hands-on. You'll get to actually install and configure some of the security features that we're going to discuss throughout the course, like App Locker, like Device Guard, BitLocker, and much more. So very cool lab. I strongly recommend that after you complete the course, you go ahead and actually do the lab to see how those technologies work. So that being said, guys, I will see you in the next lesson. This concludes our discussion about the course overview. I will see everyone in the next lesson, in which we are going to discuss, and I will actually show you step by step on how to prepare the lab environment for you to be able to go in and do the labs at the end of the course. So I'll see everyone in the next lesson, and of course I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track called Windows 10 Security Features. We are in the third lesson from the introductory section, and in this lesson, as I was mentioning in the previous lesson, you will have a hands-on lab available at the end of the course. You will actually have 5 hands-on labs available at the end of this particular course, in which you'll get to experience hands-on to implement, configure some of the security features that we'll discuss throughout the course. And in this particular lesson, I am going to explain and show you step by step how to prepare that lab environment, how to configure that lab environment. But before we get into that, of course, there are some prerequisites that we need to talk about, and of course, I will show you how to install those prerequisites. So, first of all, we need a virtualization software. And for this, you will need to download and install VirtualBox, which of course is a virtualization software. And I chose VirtualBox because it is very lightweight, very easy to use, and it doesn't require too much configuration as opposed to VMware or Hyper-V, let's say. Then you will need to download the actual virtual machines which you are going to use for the lab. For this, you will have a link available as a downloadable resource for this particular lesson, from which you can download the virtual machines. The virtual machines are already set up and pre-configured, so you just need to do the next step, import them into VirtualBox, and then go on and complete the lab. You will have a file available as a downloadable resource, of course, for this lesson, which basically contains step-by-step instructions on what you need to do, every step, every task you need to do to go on and complete the lab. There are, however, some hardware requirements for running these virtual machines. You will need to have a CPU capable of virtualization. You will need to have 8 gigabytes of RAM memory, and this is at a minimum. It will run very well on 8 gigabytes, but of course, the more the better. So the recommended amount of memory would be 16 gigabytes to run the VMs. But again, it will run absolutely fine on 8 gigabytes of RAM. This has been already tested. And last here, you will need to have at least 100 gigabytes of free space to be able to run the VMs locally on your computer. Now, the lab environment. The lab environment is composed of 3 virtual machines, as you can see here from the slide. LON DC1, this is a Windows Server 2016 domain controller with the adatum.com single domain forest configured on it. You will have also LON SVR1 with this is a Windows Server 2016 domain member server, and LON CL1, which is basically a Windows 10 Pro domain member computer with remote server administration tools installed on it. Now, one last mention here is that all computers have the Windows PowerShell remoting enabled and also have internet connectivity. Now, let's hop on to one of my lab hosts, and let me show you step by step how you would complete the prerequisites for preparing the lab environment. That is, install VirtualBox, download the virtual machines, import the virtual machines, and actually run the virtual machines. Okay, so first things first, let's download and install VirtualBox. In order to do that, we will need to go to this site over here to virtualbox.org. You'll also have the direct link available in the downloadable resources for this lesson, and let's click on Windows Host to download VirtualBox 6.1.14 for Windows. As soon as the software downloads, let's click to actually run it, and then this process is just simple as next, next, finish. So let me click next, next. I don't want to create a quick launch and register file association and so on. So let me click on next and proceed with installation and install. This will take several minutes as it says here, so I'll just leave it for a few minutes to run, and I will pause the video and resume it once it's installed. Ah, just as I was speaking, as you see, the installation is complete. So let me close down this page over here and let me start Oracle VirtualBox. Here it is. Let me maximize it so you can see it better. I have some virtual machines over here. I am going to just remove these machines just now, so you will have a fresh virtual box, because I already had it installed on this box, and that's why the machines were automatically added here when I first opened up a virtual box. So let me remove the machines very quickly. So this is how your VirtualBox software will look like after you have installed it for the first time. Now, the next thing you need to do is actually download the VMs. And in order to do that, you need to click on a link which you will have in a text file as a downloadable resource for this lesson, which will actually take you to a OneDrive account from which you can actually download the VMs. So let me minimize this for now. Let me open up a browser over here and let me just paste the download link. When you go to this link, it will probably look something like this, and you have the option to select all of these virtual machines over here. There are 3 virtual machines. Right click and click on download. Of course, you will need to sign in with a Microsoft account in order to do that. So I will just sign in with an account that I already own. So let me just put in the username over here, gmail.com. If you don't have a Microsoft account, that's not going to be a problem. You just click on create one over here. It's a 2-minute process to create a new Microsoft account. So let me put in my password. Here we go. And let me click on sign in. I don't want to stay signed in. Let me just close this. And again, let's select these virtual machines over here. Right click and click on download. As soon as you do that, you will see that it starts to download a zip archive. You will have to wait for them to be downloaded and unzip them. I will cancel this because I've already downloaded the virtual machine, so we are not going to waste any time here. So let me cancel this. Let me close down the browser, and I've already placed my virtual machines in the C drive under VMs. So this is what they will look like after you download them and unzip them. So you will have a .ova file for each virtual machine. Now the next tip is to actually import these virtual machines into a VirtualBox, and in order to do that, you have the option to file import or to just import button over here. So again, local file system, browse to the folder in which you have unzipped your virtual machines. Mine would be CVMs, and you have the option to select the virtual machine that you want to import. I will start with the domain controller. Let me click on open. Let me click on next over here. You need to leave this as it is. I will change the destination folder because I want the virtual machines to be imported over into the VMs folder. I will just name this lon dc1, and I am going to click import. Now the process takes about 10-15 minutes per VM. For some VMs that are smaller, it will take a lot less. So I'm just going to pause the video until this imports, and then I'm going to resume the video once it's finished. So the virtual machine has imported successfully, and as you can see, it's in a powered off state. Now, what I'm going to do, I'm going to repeat the process for the other two virtual machines. So click import, browse to the folder. I have unzipped the OVA files, CVMs. Now I'm going to import SVR1, sorry. Okay, open, next. I am going to choose the location to another folder here. So I'm going to go with C, if I can click. Okay, VMs, and I'm going to backslash and the name of the VM, lon svr1, and click import. Again, please repeat the same step for the other VM, lon cl1, and of course I'm going to pause the video again, not to waste your time, and resume once all of the VMs are imported. I'm going to do the same thing for lon cl1. Okay, so now that all the virtual machines have been imported, there's one last thing we need to do, and that is to create a new network, and we will attach these virtual machines to the new network. Now, don't get scared. There's not any kind of IP addressing involved or stuff like that. You just need to go to File, Preferences, over to the Network tab over here, click the plus sign over here, and create a new NAT network. That's it. Click OK. Make sure to go to each virtual machine, click on Settings, and be sure that on the network it is connected to the NAT network over here. Let me click OK. Let me check every single one of them. Network, NAT network, that's good. Okay, and LON CL1, network, NAT network. That's very, very good. Now, let's power on this virtual machines, and let's see how they look. So let me click on Start over here, and let's wait for LON DC1 to boot up. Of course, one thing I've forgot to mention while this boots up is if you have the necessary resources, and if you don't want to stick with the base memory, with the default memory that I've set of 2 gigabytes of RAM, of course you can go to each virtual machine, click on Settings, and then to the System over here. And of course the virtual machine has to be shut down when you do this, and you can increase from the slider here the amount of RAM that you allocate to this virtual machine. That was just as a side note. So let me go back to my domain controller over here. Let me exit out of this. And here we go. It is booting up right now. It's getting the devices ready because it boots up for the first time in the new environment. And in the meantime, let me just go ahead and start the other virtual machines as well. Lon SVR1, and of course, let me click out of this, and of course, lon CL1. And let's just wait for the virtual machines to actually boot up, and then I will pause the video until it boots up because I do not want to waste any kind of time. Here we go, the domain controller is up and running. So let me go to input keyboard, hit Alt Control Delete, and you will have the credentials available in the downloadable resources for the lesson, of course. So I will put in the password. Here we go. And let's see, it's up and running. So just a few things I just want to do just to show you that the machines are up and running and they are able to communicate with each others and they are connected to the same domain. So let me take a look at the other ones as well. Let me log into this one. Of course, you can of course, amend the settings for the console view as you want, as you see fit, as you like. So let me scale to 100%. So this is the LON SRV1. Let me put it over here, not to have too many. Let me Alt Control Delete into this one as well. So let me put in the password. Here we go. And let me log into the Windows 10 workstation as well. Here we go. The password. Okay. So now let me get back to the domain controller. Let me just quickly show you if I open up AD users and computers. Let me just show you that is pre-configured with all the necessary domains. It has users, it has organizational units, and so on, everything that you need. Let me open up a PowerShell session over here, and just as a good practice so you won't have any issues, first of all, when you go through each of these machines, open up a PowerShell session and do the following commandlet. Enable PS remoting and with the parameter force. Here we go. So this will basically enable the PS remoting for this machine. I will actually go ahead and do the same on all the other machines. So let me open up a PowerShell and this one as well. Let me open up as administrator and do the same as soon as it comes up, and on the Windows 10 workstation as well. So let me open up Windows PowerShell admin and wait for the session to, okay, here we go. So enable, again, PS remoting. Okay, with the parameter force. Let me hit enter to this one as well. And on the Windows 10 machine, the same, enable PS remoting with the force parameter. As soon as it comes up, it's a bit laggy, so I'll just continue typing. Here we go. So as you can see, the machines are up and running. And now one final test before we end the lesson, because every other configuration that you need to do, you will do it with the step-by-step instructions throughout the lab. So you'll need to install the ATA, you will need to download some tools, but everything else you will do it when you do the lab. So this is all you need to do to prepare the lab environment. So one last thing I want to do here, just to make sure the computers are communicating properly with each other, I'm going to ping this other server from the domain controller. So ping lon svr1. Okay, we're getting replies. That's very good. And ping lon cl1. Okay. And one more thing, just to make sure that I'm able to access the C drive of the lon SVR1 and lon CL1. And probably you will need to do this as well in the labs, because you are going to have to copy some files between the servers and the Windows 10 workstation. So // lon SVR1, oops, I forgot a dash, SVR1 C $. Perfect. And / lon CL1 C $. And I can access the C drive of the Windows 10 machine as well. So that is all you need to do, guys, to prepare the lab environment, to set up the lab environment. Now go through the course. Once you finish the course, download the lab instructions and follow the instructions. They are step-by-step instructions to basically complete the lab. You just need to fire up the VMs and then follow along with the instructions in the in the file with the lab instructions. Okay, so that's it. Let's begin the course. I'll see you in the next lesson. So I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track called Windows 10 Security Feature. We are in section 2 of the course, and this section is comprised of only one lesson in which we are going to talk about the built-in Windows 10 defenses. And more specifically, we are going to discuss about the Windows 10 defense stack and the evolution of attacks. So this is just a brief overview of these two topics, after which we'll get into the next section where we'll discuss about each and one of the Windows 10 security features. So, lesson 1, the evolution of attacks, as I was saying, the Windows 10 defense stack, and we're going to touch briefly about the security threat landscape and the evolution of attacks. So, first of all, I want to tell you that this course will provide an overview of some of the software and firmware threats faced in the current security landscape and the mitigations that Windows 10 offers in response to those threats. Now, the diagram here in the slide shows the continuum of security defenses of Windows 10 aimed at device protection, and of course they are divided, as you can see. Let me just bring up the pen over here, in pre-breach detection and post-breach mitigation. And here, of course, we have device protections, and here we have a lot of tools and security features that do that in Windows 10. Then we have the threat resistance. Then we have the identity protection. Then the information protection, of course. And after that, we have the post-breach capabilities, and that is done through a lot of security features, but lately and mostly done by Microsoft Defender for Endpoint, formerly named Microsoft Defender Advanced Threat Protection. Now, let's get into our second topic here and talk about the evolution of attacks. So today's security threat landscape is one of aggressive and tenacious threats. In previous years, malicious attackers mostly focused on gaining community recognition through their attacks or the thrill of temporarily taking a system offline. Since then, attackers' motives basically have shifted towards making money, including holding devices' data hostage until the owner pays the demanded ransom, and that is, of course, as you know, called a ransomware attack. Now, modern attacks increasingly focus on large-scale intellectual property theft, targeted system degradation that can actually result in financial loss, and now even cyber terrorism that threatens the security of individuals, businesses, and national or regional interests all over the world. These attackers are typically highly trained individuals and security experts, some of whom are in the employ of nation states that have large budgets and seemingly vast human resources. Now, the diagram here in the slide basically illustrates that evolution. First of all, the script kiddies. So the script kiddies were basically unsophisticated attackers with let's say, no vast knowledge of attacks, using just attack tools that are available online for free. Then it shifted toward, as I was saying, attackers with well-known status that perform cyber attacks for monetary reasons. And of course, lastly, we have here nation states, terrorist groups, and activists, hackers, which are, of course, as I've mentioned, very high trained and highly skilled attackers that perform cyber attacks for nation states, for terrorist groups and for activist groups. Now, threats like these require an approach that can meet this challenge, of course. First, we look at the hardware, and then we look at the software security features in the current Windows 10 operating system. Then, in the upcoming sections of the course, we look at the we look at the security features after the Windows 10 Creators Update that basically included multiple new and enhanced security features. And we will also review how the security features of Windows 10 helped to mitigate a ransomware attack, because in the last lesson of the course, of the last section of the course, we will discuss about a case study, an actual case study that involved a ransomware attack. So that being said, guys, this was just a high overview of what we are going to talk about in the course and about this evolution of attacks. So I will see everyone in the next section where we'll deep dive into the course, and the next section was called How Windows 10 Uses Modern Hardware Features for Security, in which we are going to discuss, of course, about the hardware security features embedded in Windows 10. So I'll see everyone in the next lesson, and of course, I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track, Windows 10 Security Features. We are in section 3 of the course, and in this section we are going to discuss about how Windows 10 uses modern hardware features for security. So we'll have 3 lessons in this section. We'll talk about secure boot process in the first lesson, then secure boot to trusted boot, and about additional hardware security. So in this first lesson we are going to talk about the secure boot process, and specifically we are going to discuss about understanding the background for UEFI secure boot, an overview of the startup process, trusted platform module, that is TPM, about Windows 10 automatic TPM initialization, and about practical applications. So that being said, let's dive into our first topic here in the lesson and talk about understanding the background for Unified Extensible Firmware Interface Secure Boot. That is the UEFI Secure Boot. Now, Secure Boot with Unified Extensible Firmware Interface is not new in Windows 10, but is a key part of the overall security process. UEFI replaced the venerable basic input-output system firmware, that is the BIOS. So UEFI Secure Boot is a security standard for firmware built into PCs by manufacturers beginning with Windows 8. It helps to protect the startup process and firmware against tampering, such as from physically present attacker or from forms of malware that run early in the startup process or in the kernel after startup. Now, a device running Windows 10 has several requirements for starting up into the operating system. After the device's firmware initializes, all the hardware, the device must ensure that there is enough power to start up. Next, the device must ensure that the device is starting up into the appropriate operating system, depending on whether the user wants to perform an update or a restore on the device, or if the user wants to start up the device into the main operating system. Now, let's take a look at an overview of the startup process so everyone understands what actually happens when the device is started up, let's say, right? And let me bring up my pen over here to highlight some of these steps. So first of all, the first step is that the device is powered on, right? So the device is powered on and runs the system on a chip, that is SOC, right? runs the system on a chip specific firmware bootloaders, which initialize the minimal set of hardware required for the device to run. The system on a chip firmware bootloaders are designed to finish as fast as possible, and nothing is drawn to the screen while they are running. After the system on a chip firmware bootloaders finish, the device is started into the UEFI environment. Now, the next step is the firmware bootloaders over here. So the firmware bootloaders start up the UEFI environment and hands over control to the UEFI applications written by the system on a chip vendor, Microsoft, and OEMs, right? These applications can utilize UEFI drivers and services. Then the entire UEFI environment launches, and this is the main step over here, right? So the UEFI environment launches the Windows Boot Manager, right? Which determines whether to start up the FFU flashing or device reset mode to the update OS or the main OS. And when I say OS, I'm referring to the operating system, of course. The UEFI environment is a minimal startup operating system on its own, upon which devices are started and then Windows 10 operating system runs. Now, as you can see in the UEFI environment, there are a lot of things that are happening here, that are going on, but don't worry, we'll get to those throughout the course in more detail. And of course, you will also have links to additional reading available as downloadable resources for this lesson. Now, the next step is the Windows Boot Manager. The Windows Boot Manager, right? And this is the one over here that's inside of the UEFI environment. So the Windows Boot Manager is a Microsoft-provided UEFI application that sets up the environment and starts up the environment, right? So you can think of it this way. Windows Boot Manager basically sets up the startup environment for the operating system to load. Inside the startup environment, individual startup applications started by the boot manager provide functionality for all customer-facing scenarios before the device starts up. And as you can see, there are a lot of things going on here inside the boot manager, and it's the WP-DMP.exe is launched, then mobile startup .exe is launched as well. And of course, we'll talk about that throughout the course in more detail. Okay, then in all the OS images, the boot manager next runs the mobile startup EFI, what I was mentioning earlier, right? This application basically runs several startup libraries, and these are the boot libraries that it actually runs, okay? And some of these libraries are only run on first startup. For example, let's say to provision the secure startup policy. Now, if the mobile startup.exe does not start up to flashing or device reset mode, the boot manager then starts up into the main operating system or the update OS. And these are the steps over here. So it either goes into the main operating system or it goes into the update OS. And that is basically the startup process at a high level overview, right? Now, the Windows Boot Manager, again, as I was saying, is a UEFI application that sets up the environment, and of course, you will find links to additional reading in regards to this in the downloadable resources for this lesson. Now, one note here. So, in the 1703 Creator release of Windows 10, Microsoft included a new utility called MBR2GPT that basically converts a working BIOS MBR-based system to UEFI GPT system. Now, it is recommended to be run from the Windows recovery environment, and this only works with the 1703 release of Windows 10 or later. So once your system drive is converted to GPT, you need to change your firmware setting to start up from UEFI GPT instead of the old BIOS MBR startup. Now, again, you will find additional links to more details in regards to these two topics in the downloadable resources for this lesson, and of course, the best practices for this. Now, let's talk about our next topic here, and that is the Trusted Platform Module, TPM. So the Trusted Platform Module, or TPM, technology is designed to provide hardware-based security-related functions. A TPM chip is a secure crypto processor that is designed to carry out cryptographic operations. The chip includes multiple physical security mechanisms to make it tamper-resistant, and malicious software is unable to tamper with the security functions of a TPM. Some of the key advantages of using TPM technology are that you can generate, store, and limit the use of cryptographic keys. Then you can use the TPM technology for platform device authentication by using the TPM's unique RSA key, which is burned into it, physically burned into it, and that is the capability over here. So one root of trust composed of incontrovertible code and key, right? So this RSA certificate is one part of Windows Hello. It is the something you have, basically a key protected by the TPM, right? This, along with your PIN, that is something you know, basically forms a multi-factor authentication login. So we will discuss about Windows Hello and Windows Flow for Business in a later section of this course. And then, lastly, you can help ensure platform integrity by taking and storing security measurements. Now, the most common TPM functions are used for system integrity measurements and for key creation and use. During the startup process of a system, the startup code that is loaded, this includes the firmware and the operating system components, can be measured and recorded in the TPM. The integrity measurements can be used as evidence for how a system started and to make sure that a TPM-based key was used only when the correct software was used to start up the system. The TPM-based keys can be configured in a variety of ways. One option is to make a TPM-based key unavailable outside of the TPM. This is, of course, good to mitigate phishing attacks because it prevents the key from being copied and used without the TPM. TPM-based keys can also be configured to require an authorization value to use them. If too many incorrect authorization guesses occur, of course, the TPM will activate its dictionary attack logic and prevent further authorization value guesses. So now let's talk about the Windows 10 automatic TPM initialization. So starting with Windows 10, the operating system automatically initializes and takes ownership of the Trusted Platform Module. So this means that in most cases, the recommendation is that you avoid configuring the TPM through the TPM management console, that is tpm.msc. There are a few exceptions, mostly related to resetting or performing a clean installation on a PC. In certain specific enterprise scenarios, limited to Windows 10 versions 15.07 and 15.11, group policy might be used to back up the TPM owner authorization value into Active Directory. Because the TPM state persists across operating system applications, this TPM information is stored in a location in Active Directory that is separate from computer objects. Backing up the TPM key to Active Directory allows an enterprise to recover the encrypted content if the need arises. So that being said, let's take a look at some practical applications that the TPM would apply to. And the first one is certificates. So certificates can be installed or created on computers that are using the TPM. After a computer is provisioned, the RSA private key for a certificate is bound to the TPM and cannot be exported. The TPM can also be used as a replacement for smart cards, which basically reduces the costs associated with creating and distributing the cards. Now, then we have another practical application, and that is the automated provisioning in the TPM. The automated provisioning in the TPM reduces the cost of the TPM deployment in an enterprise. New APIs for TPM management can determine if the TPM provisioning actions require physical presence of a service technician to approve TPM state change requests during the startup process. And then lastly, we have here, sorry, I've changed the slide by mistake. Lastly, we have here the anti-malware software that can, of course, use the startup measurements of the operating system start state to provide integrity of a computer running Windows 10 or Windows Server 2016. These measurements include the launch of Hyper-V to test that data centers using virtualizations are not running on trusted hypervisor. Of course, with BitLocker network unlock, again, IT administrators can push and update without concerns that a computer is waiting for a PIN entry. Now, the TPM has several group policy settings that might be useful in certain enterprise scenarios, and of course, for more information in regards to this, please see the downloadable resources for this lesson, in which you'll find links to additional readings and more details on these particular topics. Now, that being said, this concludes our discussion for this particular lesson. I will see everyone in the next lesson, where we'll discuss about the secure boot to trusted boot process. So I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track called Windows 10 Security Features. We are in section 3 of the course, and this is the second lesson in which we are going to discuss about secure boot to trusted boot. And more specifically, first of all, we are going to discuss what are the threats, the actual threats, and here we have rootkits and bootkits. Then about the Windows 10 countermeasures, about the Windows 10 startup process, about the secure boot, trusted boot, and measured boot. So, when you run Windows 10 on a PC or any device that supports UEFI, Trusted Boot protects your PC from malware from the moment you power on your PC until your anti-malware starts. In the unlikely event that malware does infect a PC, it can't remain hidden. Trusted Boot can prove the system's integrity to your infrastructure in a way that malware can't disguise. Even on PCs without UEFI, Windows 10 provides even better startup security than previous versions of Windows. So let's take a look at how they work. So what are the threats? The threats during the startup process, of course, are rootkits and bootkits. So rootkits are sophisticated and dangerous type of malware that run in kernel mode, using the same privileges as the operating system. Because rootkits have the same rights as the operating system and start before it, they can completely hide themselves and other applications. Often, rootkits are part of an entire suite of malware that can bypass local logins, record passwords, keystrokes, transfer private files, and capture cryptographic data. Now, different types of rootkits load during different phases of the startup process. And let's kind of take a look at these and how they work. So first we have the firmware rootkits. And let me just bring up my pen over here. The firmware rootkits. And these kits override the firmware of the PC's basic input-output system or other hardware so that the rootkit can start actually before Windows starts. Then we have the bootkits. And these kits replace the operating system's bootloader, and that is the small piece of software that actually starts the operating system, and it replaces it so that the PC loads the bootkit before the operating system again. Then we have the kernel rootkits. And these kits replace a portion of the operating system's kernel so that the rootkit can start automatically when the operating system loads. And last but no means least, we have the driver rootkits. And these kits pretend to be one of the trusted drivers that Windows uses to communicate with the PC's hardware. Now that we've established that, let's take a look at what would be the Windows 10 countermeasures. So Windows 10 supports 4 features to help prevent rootkits and bootkits from loading during the startup process. The first one, of course, is the secure boot over here. So PCs with UEFI firmware and TPM can be configured to load only trusted operating system bootloaders. The secure boot assures the integrity and confidentiality of the flash contents, and if you see a message with a red, and we'll talk about this, and you'll have the picture on the next slide with a red warning saying that secure boot has been violated, then it means that the secure boot has detected an invalid or unsigned executable. Again, then we have the trusted boot, another of the 4 features. And here Windows checks the integrity of every component of the startup process before loading it. Then we have the early launch anti-malware, that is shortly ELAM. And ELAM basically tests all drivers before they load and prevents unapproved drivers from loading. And lastly, we have the measured boot, and the PC's firmware logs actually the startup process, and Windows can send it to a trusted server that can objectively assess the PC's health. Now, if we take a look at the following process over here, this basically shows the startup process and where a bootkit would fit in and where a rootkit would fit in during the startup process, of course. Now, the secured boot and measured boot are only possible on PCs with UEFI 2.3.1 and a TPM chip. Now, fortunately, all Windows PCs that meet Windows hardware compatibility program requirements have these components, and many PCs designed for earlier versions of Windows also have them. So again, as we can see, the bootkit would fit into the earlier steps of the startup process, and the rootkit would fit into the next steps of the startup process. But very important, all of these are before the operating system actually loads up. Now, let's take a look and discuss in more details about the secured boot. And this is the actual violation that I've mentioned earlier. This would be the warning message. Now, when a PC starts, it first finds the operating system bootloader. PCs without secure boot just run whatever bootloader is on the PC's hard drive. There's no way for the PC to tell whether it's a trusted operating system or a rootkit. When a PC equipped with UEFI starts, the PC first verifies that the firmware is digitally signed, reducing the risk of firmware rootkits, right? If secure boot is enabled, the firmware examines the bootloader's digital signature to verify that it hasn't been modified. If the bootloader is intact, the firmware starts the bootloader only if one of the following conditions are true. The bootloader was signed by a trusted certificate. This is one of the conditions. So the chain of trust is like the public key infrastructure found in browsers, right? In the case of PCs certified for Windows 10, the Microsoft certificate is trusted. The other condition that needs to be met is the user has manually approved the bootloader's digital signature. And this basically allows the user to load non-Microsoft operating systems like Linux or Unix. Now, all PCs on 32-bit based operating system must meet several requirements related to secure boot. And here you have them. So they must have secure boot enabled by default. They must trust Microsoft certificate, and thus any bootloader Microsoft has signed, of course. So Microsoft offers a service to analyze and sign any non-Microsoft bootloaders so that it will be trusted by all certified Windows 10 PCs. So, in fact, you will find in the downloadable resources for this lesson a link which takes you to an open source bootloader capable of loading Linux that is already available. So you'll find the link in the downloadable resources. Then, the computers must allow the users to configure secure boot to trust other bootloaders, and all certified for Windows 10 PCs allow you to trust a non-certified bootloader by adding a signature to the UEFI database, allowing you to run any operating system, including homemade operating systems. And the last condition here, they must allow the user to completely disable the secure boot. And all certified Windows 10 PCs allow you to turn off secure boot so that you can run any software. Now, this does not help protect you from bootkits, however. These requirements help protect you from rootkits while allowing you to run any operating system you want, as we've seen. Now, to prevent malware from abusing these options, the user must manually configure the UEFI firmware to trust a non-certified bootloader or turn off secure boot. Software cannot change the secure boot settings. Now, let's go on and talk about the trusted boot. So, trusted boot takes over where secure boot leaves off. The bootloader verifies the digital signature of the Windows 10 kernel before loading it. The Windows 10 kernel, in turn, verifies every other component of the startup process, including the startup drivers, startup files, and ELAM, early launch anti-malware. If a file has been modified, the bootloader detects the problem and refuses to load the corrupted component. Often, Windows 10 can automatically repair the corrupted component. It will look to the designated Windows Update service for a replacement to the modified file, restoring that integrity of the Windows and allowing the PC to start normally. And that is what actually trusted boot does. Now, measured boot. So, if a PC in your organization does become infected with a rootkit, you need to know about it. Enterprise anti-malware apps can report malware infection to the IT department, but that doesn't work with rootkits that basically hide their presence, right? In other words, you can't trust the client to tell you whether it's healthy or not. So as a result, PCs infected with rootkits appear to be healthy, even with anti-malware running. Infected PCs continue to connect to the enterprise network, giving the rootkit access to vast amounts of confidential data and potentially allowing the rootkit to spread across the internal network, right? So working with a TPM and Microsoft or non-Microsoft software, measured boot in Windows 10 allows a trusted server on the network to verify the integrity of the Windows startup process. So measured boot uses the following process. First of all, the PC's UEFI firmware stores in the TPM a hash of the firmware, bootloader, startup drivers, and everything that will be loaded before the anti-malware op starts. So, as you can see, this is stored here, right? At the end of the startup process, Windows starts the remote attestation client. And this is the remote attestation client over here in our measured boot process. The trusted attestation server sends the client a unique key, as you can see here. Here we go. Then the TPM uses the unique key to digitally sign the log recorded by UEFI, and the client then sends back this sends back this log to the server, possibly with other security information. And depending on the implementation and configuration, the server can now determine whether the client is healthy and grant the client access to either a limited quarantine network or to the full network. So Windows 10 includes the application programming interfaces to support measured boot. Microsoft's Azure Active Directory and Microsoft's Intune mobile device management also support remote health attestation. Device health attestation enables enterprises to establish a trust based on hardware and software components of a managed device. With device health attestation, of course, you can configure an MDM server to query a health attestation service that will allow or deny a managed device access to a secure resource on the network. Of course, the device must be running Windows 10 and it must support at least TPM 2.0. Now, let's take a look about some things that you can actually check on the device. So, first of all, you can check if data execution prevention is enabled. Then you can check if BitLocker drive encryption is supported and enabled, of course. And lastly, you can check if the secure boot is supported and enabled. So, as you can see, measured boot uses the power of UEFI, TPM, and Windows 10 to give you a way of confidentially assess the trustworthiness of a client PC across the network. Secure boot, trusted boot, and measured boot create an architecture that is fundamentally resistant to bootkits and rootkits. In Windows 10, these features have the potential to eliminate kernel-level malware from your network, and this is the most groundbreaking anti-malware solution that Windows has ever came up with, let's say. Of course, you will find links to additional resources to in more details reading about all of the topics that we've discussed here in the downloadable resources for this lesson, which I highly recommend that you go through. And this being said, this concludes our discussion for this particular lesson. And of course, I will see everyone in the next one, where we'll talk about additional hardware security in Windows 10. I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track, Windows 10 Security Features. We are in section 3 of the course, and this is the last lesson of this section, in which we are going to discuss about additional hardware security. And more specifically, we are going to talk about the early launch anti-malware, the data execution prevention, address space layout randomization, protected processes, heap protection, and kernel pool protection. That being said, let's get into our first topic here in the lesson and talk about the early launch anti-malware. So because Secure Boot has protected the bootloader and Trusted Boot has protected the Windows kernel, The next opportunity for malware to start is by infecting a non-Microsoft startup driver. Traditional anti-malware apps don't start until after the startup drivers have been loaded, giving a rootkit, for example, disguised as a driver, the opportunity to work its magic, let's say. Early launch anti-malware, or shortly ELAM, can load a Microsoft or non-Microsoft anti-malware driver before all non-Microsoft startup drivers and applications, thus continuing the chain of trust established by Secure Boot and Trusted Boot. Because the operating system hasn't started yet, and because Windows needs to start up as quickly as possible, ELAM has a simple task. Examine every startup driver and determine whether it is on the list of trusted drivers or not. If it's not trusted, Windows won't load it. Now, the ELAM feature is not new, as you can see here on the slides. It's been there since Windows 8. Now, an ELAM driver isn't a full-featured anti-malware solution that, let's say, loads later in the startup process. Windows Defender, included in Windows 10, supports ELAMs, as does Microsoft System Center 2012 Endpoint Protection and several non-Microsoft anti-malware apps. The name of the Windows Defender ELAM driver is wdstartup.sys. Windows Defender in Windows 10 uses its ELAM driver to roll back any malicious changes made to the Windows Defender driver at the next restart. This basically prevents kernel mode malware making lasting changes to Windows Defender's mini-filtered driver before shutdown or restart. Now again, the ELAM signed driver is loaded before any other third-party drivers or applications, which basically allows the anti-malware software to detect and block any attempts to tamper with the startup process by trying to load unsigned or untrusted code. The ELAM driver is a small driver with a small policy database that has a very narrow scope, focused on drivers that are loaded early at system launch. The policy database is stored in a registry hive that is also measured to the TPM to, of course, record the operational parameters of the ELAM driver. An ELAM driver must be signed by Microsoft, and the associated certificate must contain the complementary enhanced key usage of the ELAM driver. Now, that being said, let's go on and talk about our next topic here, and that is data execution prevention, or shortly DEP. So data execution prevention, DEP, is a system-level memory protection feature available in Windows operating systems. DEP enables the operating system to mark one or more pages of memory as non-executable, which in turn prevents code from being run from that region of memory, to help, of course, prevent exploitation of, let's say, buffer overflow attacks. And, of course, you'll have a link to further documentation on this topic, on what exactly does buffer overflow attack means, and we've also discussed this in another, more in depth in another course in the series. Okay, so DEP helps prevent these attacks by basically intercepting them and raising an exception. DEP is not new. Actually, it was introduced in Windows XP Service Pack 2. Okay, now let's see how DEP works. And let me bring up my pen over here. So if an application attempts to run code from a protected page, the application receives an exception with a status code status access violation. This one over here. If your application must run code from a memory page, it must allocate and set the proper virtual memory protection attributes. The allocated memory must be marked as either page execute read, page execute read write or page execute write copy when allocating the memory. And these are the parameters over here. Heap, which is another feature which we'll discuss shortly. Heap allocations made by calling the malloc and the heap alloc functions are basically non-executable. So applications cannot run code from the default process heap or the stack. This feature is what prevents the buffer overflow exploitation attack. DEP is configured at system startup according to the no execute page protection policy setting in the startup configuration data. An application can get the current policy by calling the get system dep policy function, this one over here, and depending on the policy setting, an application can also change the dep setting for the current process by calling the set process dep policy function, and this is the one over here. Now, data execution prevention helps prevent code from being run from data pages such as the default heap, stacks, and memory pools. Although some applications have compatibility problems with dep, most applications do not. Now, to actually see what applications are using dep, you can start the task manager, and in fact, let me just bring it up over here and let me show you exactly what I'm talking about. Let me enlarge it. So as you can see, you can start up the task manager over here. Then you can go to the details tab over here. Then I've already added the data execution prevention, but it's not added by default. You just need to right click on every head column over here, click on select columns, and go all the way down to find data execution prevention over here and check the box next to it, and then the column will appear. As you can see, all of these applications have data execution prevention enabled, so all of them are using data execution prevention. Okay, let's go back to the slides and let's discuss about our next topic over here, and that is the address space layout. Now, one of the most common techniques used to gain access to a system is to find a vulnerability in a privileged process that is already running. Guess or find a location in memory where important system code and data have been placed, and then overwrite that information with a malicious payload. Any malware that could write directly to the system memory could simply overwrite it in well-known and predictable locations. Well, address space layout randomization, or shortly ASLR, makes that type of attack much more difficult because it randomizes how and where important data is stored in memory. With ASLR, it is more difficult for malware to find the specific location it needs to attack. Now, the diagram here on the slide illustrates how ASLR works by showing how the locations on different critical Windows components can change in memory between restarts. So, Windows 10 applies ASLR across the system memory and increases the level of randomness many times compared with previous versions of Windows to combat sophisticated attacks such as heap spraying. Again, you will have another link which explains what is heap spraying and how it is performed. 64-bit system and application processes can take advantage of a vastly increased memory space, which makes it even more difficult for malware to predict where Windows 10 stores vital data. When used on systems that have TPMs, ASLR memory randomization will be increasingly unique across devices, which makes it even more difficult for a successful exploit that works on one system to work reliably on another system. Group policy can be used to control ASLR using the process mitigation options. Again, you will have details about the overriding the process mitigation in the downloadable resources for this lesson. You will have links with additional reading and more details. You can also use the group policy setting called process mitigation options to control the ASLR settings and options. Okie dokie, let's get back to our next topic over here and talk about the protected processes. Most security controls are designed to prevent the initial infection point, right? However, despite all the best preventive controls, malware might eventually find a way to infect a system. So some protections are built to place limits on malware that gets on the device. Protected processes creates just that, limits of this type. With protected processes, Windows 10 prevents untrusted processes from interacting or tampering with those that have been specially signed. Protected processes defines levels of trust for processes, and less trusted processes are prevented from interacting with and therefore attacking the more trusted processes. Windows 10 uses the protected processes more broadly across the operating system, and as in, for example, Windows 8.1, implements them in a way that can be used by non-Microsoft anti-malware vendors. Again, you'll have more links to more additional reading in regards to protecting anti-malware services in the downloadable resources for this lesson. And of course, as you can see, this helps make the system and anti-malware solutions less susceptible to tampering by malware that does manage to get on the system. With the protected processes feature, Windows 10 prevents untrusted processes from interacting or tampering with those that have been specially signed. Okay, now let's talk about heap protection. The heap is a location in memory that Windows uses to store dynamic application data. Windows 10 continues to improve on earlier Windows heap designs by furthering mitigating the risk of heap exploits that could be used as a part of an attack. Windows 10 has several important improvements to the security of the heap. One of them being heap metadata hardening, and this is for internal data structure that heap uses to improve protections against memory corruption. Then the heap allocation randomization, that is the use of randomized locations and sizes for heap memory allocations, which makes it more difficult for an attacker to predict the location of critical memory to overwrite. Specifically, Windows 10 adds a random offset to the address of a newly allocated heap, which makes the allocation much less predictable. Then you have heap guard pages before and after blocks of memory, which work as tripwires, let's say, right? If an attacker attempts to write past a block of memory, that is, of course, a common technique known as a buffer overflow, the attacker will have to overwrite a guard page. Any attempt to modify a guard page is considered a memory corruption, and Windows 10 responds by instantly terminating the application. Now, again, you will find, let's say, a very beautiful explanation of the heap manager in the downloadable resources for this lesson, which I recommend that you go in and read about it. And now let's talk about the kernel pool protections. Now, the operating system kernel in Windows sets aside two pools of dynamically allocated memory, one that remains in the physical memory, non-paged pool, and one that can be paged in and out of physical memory, and that is the paged pool. Now, this memory is shared between all kernel functions and device drivers. There are many types of attacks that have been attempted against these pools, such as process quota pointer encoding, look-aside, delay-free, and pool page cookies, and pool index bound checks. Windows 10 has multiple pool hardening protections, such as integrity checks, that help protect the kernel pool against such attacks. Now, you'll have a link, a very, very cool and useful link in the downloadable resources for this lesson, which details basically a description of kernel pool exploitations on Windows 7. So in addition to this pool hardening that I was mentioning, Windows 10 includes other kernel hardening features such as kernel dep and kernel address space layout randomization. So that is the dep, the data execution prevention, and address space layout randomization, which we've talked about, but this is specifically for the kernel, right? Then you have font parsing in app container, font parsing in app container over here, and this basically isolates font parsing in an app container sandbox. Then you have the disabling of anti-virtual DOS machine, anti-VDM, right? The old anti-VDM kernel module for running 16-bit applications is disabled by default, which neutralizes the associated vulnerabilities. Enabling the anti-VDM decreases the protection against null dereference and other exploits. You will find an explanation of the null dereference in the downloadable links that I've mentioned earlier. Then you have the supervisor mode execution prevention, the SMEP, and this helps prevent the kernel, the supervisor, from executing code in user pages, a common technique used by attackers for local kernel elevation of privilege, and basically this requires processor support found in the Intel Ivy Bridge or later processors, or ARM with PXM support. Then you have the safe unlinking, and this helps protect against pool overruns that are combined with unlinking operations to create an attack. Windows 10 includes global safe unlinking, which extends heap and kernel pool safe unlinking to all usage of list entry and includes the fast fail mechanisms to enable rapid and safe process termination. Now, again, for a deep dive in this topic, see the downloadable resources for this lesson, where you'll have a link which takes you to an article called Software Defense, Safe Unlinking, and Reference Count Hardening. Then, lastly, you have memory reservations, and the lowest 64 kilobytes of memory, of process memory, is reserved for the systems. Right? Apps are not allowed to allocate that portion of the memory. This makes it more difficult for malware to use techniques such as the null dereference to overwrite critical system data structures in memory. Okay, that being said, this basically concludes our discussion for this lesson and for this section, in which we've had a high overview, a high detail overview, and we've summarized, let's say, the hardware security features of Windows 10. I will see you everyone in the next section, in which we'll discuss about the Windows 10 software security features, part 1. So I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track called Windows 10 Security Features. We are in section 4 of the course, and this is the last lesson of this section, in which we are going to discuss about the antivirus and Windows Information Protection. And specifically, we are going to cover Windows Defender Antivirus. We are going to see how to evaluate Windows Defender Antivirus Protection, Windows Information Protection, and Windows Information Protection modes. So that being said, let's get into the first topic here. and talk about the Windows Defender antivirus. So Windows 10 includes Windows Defender Antivirus, or shortly WDAV, that is a robust bundled anti-malware solution. Windows Defender Antivirus has been continually improved since it was introduced in Windows 8. Windows Defender Antivirus in Windows 10 uses a multi-pronged approach to improve anti-malware capabilities. And that is, first of all, it is cloud-delivered protection. Okay, so one note here, Windows 10 Creators Update feature helps detect and block new malware within seconds, even if the malware has never been seen before. The service uses distributed resources and machine learning to deliver protection to endpoints at a rate that is far faster than the traditional signature updates. Then you have rich local context. Since this improves how malware is identified. Windows 10 informs Windows Defender Antivirus not only about content like files and processes, but also where the content came from, where it has been stored, and more information. Now, the information about source and history enables Windows Defender to apply different levels of scrutiny to different content. Then you have extensive global sensors that basically help keep Windows Defender Antivirus current and aware of even the newest malware. This is accomplished in two ways: by collecting the rich local context data from endpoints, and then by centrally analyzing the data. Then you have tamper proofing. And this helps guard Windows Defender itself against malware attacks. For example, Windows Defender Antivirus uses protected processes, which prevents untrusted processes from attempting to tamper with the Windows Defender Antivirus components, its registry keys, and so on. And last but no means least, enterprise level features that basically give IT pros the tools and configuration options necessary to make Windows Defender Antivirus an enterprise-class anti-malware solution. Now, you can deploy, manage, and report on Windows Antivirus in many ways. As the Windows Defender AV client is installed as a corporate part of Windows 10, traditional deployment of a client to your endpoints does not apply. Deployment here refers to ensuring that Windows Defender Antivirus component is available and enabled on endpoints or servers. In most cases, Windows 10 will disable Windows Defender AV if it finds another antivirus product running and up to date. You must disable or uninstall non-Microsoft antivirus products before Windows Defender AV will be functioning. If you re-enable or install non-Microsoft antivirus products, then Windows 10 automatically again disables Windows Defender AV. Now, configuration of features and protecting, including configuring product and protection updates, are further, we will further discuss that in the Configure Windows Defender features section. Now, for the latest recommendations for real-world deployment and monitoring of Windows Defender AV, please see the downloadable resources from this lesson with a blog article called Deploy, Manage, and Report on Windows Defender AV topic. And, of course, this can be managed through System Center Configuration Manager, Group Policy, Active Directory, Microsoft Azure, Microsoft Intune, newly Microsoft Endpoint Manager, Unified Endpoint Manager, PowerShell Commandlets, and Windows Management Instrumentation, WMI. Now, evaluating Windows Defender AV protection. If you're an enterprise security administrator and you want to determine how well Windows Defender Antivirus protects you from viruses, malwares, and potentially unwanted applications, then you can use the guide which you'll find in the downloadable resources for this lesson to help you evaluate Microsoft protection. It basically explains the important features available for both small and large enterprises in Windows Defender and how they will increase malware protection and detection across the network. You can choose to configure and evaluate each setting independently or all at once. So there's a grouped similar settings based upon typical evaluation scenarios, and these include instructions for using PowerShell, for example, to enable these settings. The guide will be available, so there's a link in the downloadable resources. When you sorry, click and go to that link, you will basically download a PDF. So the guide is in PDF format. You can also download a PowerShell script that will enable all the settings described in the guide automatically. Again, you can obtain the script alongside with the PDF download, or you can obtain the script individually from the PowerShell gallery, for which you'll have another link in the downloadable resources. So again, Windows AV helps protect your computer from spyware, malware, and viruses. Windows Defender also is aware of Microsoft Hyper-V, which means that it won't flag virtual machines as a virus. Windows Defender uses definitions to determine if software that is detected is unwanted, and it alerts you about potential risks. Now, to help keep definitions up to date, Windows Defender automatically installs new definitions as they are released. One single note here, that it is recommended that you use and keep updated versions of your AV solution, whether you use Windows Defender or a non-Microsoft AV solution. So that being said, let's hop on to our next topic here and talk about Windows Information Protection. So Windows Information Protection, or shortly known as WIP, previously known as Enterprise Data Protection, helps to protect against this potential data leak without otherwise interfering with the employee experience. So WIP also helps to protect enterprise apps and data against accidental data leak on enterprise-owned devices and personal devices that employees bring to work without requiring changes to your environment or other apps. So with Windows Information Protection, includes now the functionality necessary to identify personal and business information, determine which apps have access to it, and provide the basic controls necessary to determine what users are able to do with business data, like, for example, copy and paste restrictions, and so on. Windows Information Protection is designed specifically to work with the Office 365 Pro Plus and Azure Rights Management to extend data protection for data before that data leaves the device, such as when an email attachment is sent from an enterprise-aware version of a rights management mail client. Windows Information Protection is included in Windows 10 and works behind the scene to protect data whether it lives on the device. Now, specifically, Windows Information Protection provides separation between personal and corporate data, so provides obvious separation between personal and corporate data without requiring the employees to switch environments or apps. It also provides additional data protection for existing line of business applications without a need to update the apps. It also provides the ability to wipe corporate data from the devices while leaving personal data alone. You can use audit reports for tracking issues and remediation actions, of course, and it also offers integration with your existing management systems like Microsoft Intune, System Center Configuration Management, or your current mobile device management to configure, deploy, and manage Windows Information Protection for your company. Now, with Windows Information Protection, let me just move the slides over here. just 1 second. With Windows Information Protection, you can basically encrypt enterprise data on employee-owned and corporate-owned devices. You can remotely wipe enterprise data off managed computers. You can select specific apps that can access enterprise data called allowed apps that are clearly recognizable to employees, and your employees won't have their work otherwise interrupted while switching between personal and enterprise apps. Now, let's talk about the Windows Information Protection modes. So, enterprise data is automatically encrypted after it's loaded on a device from an enterprise source or if an employee marks the data as corporate. Then, when the enterprise data is written to disk, Windows Information Protection uses the Windows provided encrypted file system, EFS, to protect and associate it with your enterprise identity. Your Windows Information Protection policy includes a list of trusted apps that can access and process corporate data. This list is implemented through the App Locker feature and functionality. We've discussed about App Locker previously in the course. So controlling basically what apps can run and letting the Windows operating system know that the apps can edit corporate data. Apps included on this list don't have to be modified to open corporate data because their presence on the list allows Windows to determine whether to grant them access or not. However, new for Windows 10, app developers can use the new set of application programming interfaces, a new set of APIs, to create enlightened apps that can use and edit both enterprise and personal data. A huge benefit to working with enlightened apps is that dual-use apps like Microsoft Word can be used with less concern about encrypting personal data by mistake because the APIs allow the app to determine whether data is owned by the enterprise or if it's personally owned. Now, the Windows Information Protection is policy-driven, and these policies can be created using the classic Microsoft Intune console, the new Microsoft Unified Endpoint Manager console, the Azure Microsoft Intune portal, or System Center Configuration Manager. So Windows Information Protection policy can be set up to use one of 4 protection and management modes. And these are hide overrides over here, allow overrides, silent, and off. And on the table here on the slide, you have a description about what each of these mode does. So please take a moment and examine the table here on the slide. Read the description of what each mode does because it's very, very helpful. Now, again, for more information about setting Windows Information Protection modes, you will have links in the downloadable resources for this lesson, which take you to blogs and articles called Create a Windows Information Protection Policy using Intune and Create and Deploy a Windows Information Protection Policy using Configuration Manager. Of course, depending on your management solution. That being said, before we conclude this lesson, I want to let you know that as a bonus for this particular section, you will have available a PDF file with networking PowerShell commandlets. So, although you can use the graphical tools to perform all network configuration and management tasks, sometimes it can be quicker to use command line tools and scripts. And Windows has always provided the command prompt for certain network management tools. However, Windows PowerShell provides a number of network-specific commandlets that you can use to configure, manage, and troubleshoot Windows network connection. And in this PDF, you will have a table which lists some of the network-related Windows PowerShell commandlets and a description of their purpose. So, For example, to configure IPv4 settings for a network connection by using Windows PowerShell, you would use the setnet IP address command. Again, please download the PDF from the downloadable resources, take a look at the table, see what each commandlet does. Go ahead and feel free to test it on your computer, because I think it is very useful. So that being said, this concludes our discussion for this lesson and for this section as well. And I will see everyone in the next section, in which we are going to talk about Windows 10 software security features part 2. And here we will cover the additional built-in software security features. And again, I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track, Windows 10 Security Features. We are in section 4 of the course, and in this one we are going to discuss about Windows 10 Security Features, the first part. And mainly, there are 3 lessons in which we are going to talk about, firstly, Windows Defender Firewall and Virtual Secure Mode, then about Credential Guard and BitLocker, and then about the antivirus and Windows Information Protection. So in this first lesson, we are going to discuss about Windows Defender Firewall and about Virtual Secure Mode. And more specifically, we're going to have an overview of Windows Defender Firewall, Windows Defender Firewall benefits, then how to access Windows Defender Firewall. Then we'll talk about the Virtual Secure Mode overview, about trustlets, and about components involved in the logon process. So let's get into our first topic here and talk about Windows Defender Firewall. So Windows Defender Firewall, or WDF, is an important part of a layered security model. Now, in later builds of Windows 10, this is called Windows Defender Firewall with Advanced Security. Now, by providing a host-based two-way network traffic filtering for a device, Windows Defender Firewall blocks unauthorized network traffic flowing into or out of the local device. Windows Defender Firewall also works with network location awareness so that it can apply security settings appropriate to the types of network to which the device is connected. Windows Defender Firewall settings and many Internet Protocol settings, those are IPsec settings, are integrated into a single Microsoft Management Console, MMC, named Windows Defender Firewall with Advanced Security. Now, this is also an important part of your network's isolation strategy. Now, in a previous course from the track, we have discussed the importance of using privileged administrative workstations, or PAW, which is a hardened device used to protect privileged credentials. IPsec can be used to ensure an administrator can only make, let's say, an RDP connection to their domain controllers from a privileged access workstation. So by imposing this restriction, we can limit the risk of exposing highly privileged credentials to a keyboard logger program on, let's say, a less trusted system, such as an administrator's standard workstation. Now, an additional benefit is that we restrict how stolen credentials can be used unless an administrator's from privileged access workstation is also acquired. Now, you will have, again, a link to a very cool article for additional reading called Securing RDP with IPsec. Now, let's take a look at some practical applications, and then we'll take a look at some benefits, let's say, in regards to Windows Defender Firewall with Advanced Security. So, practical applications to help address your organization network security challenges. Windows Defender Firewall basically offers the following benefits. First of all, it reduces the risk of network security threats. So Windows Defender Firewall with Advanced Security reduces the attack surface of a device, providing an additional layer of defense in-depth model. Reducing the attack surface of a device increases the manageability and decreases the likelihood of a successful attack, of course. Then the other benefit would be that it safeguards sensitive data and intellectual property. So with its integration with IPsec, Windows Defender Firewall with Advanced Security provides a simple way to enforce authenticated end-to-end network communication. It provides scalable, tiered access to trusted network resources, helping to enforce integrity of the data and optionally helping to protect confidentiality of the data. And then, last but not least, it extends the value of existing investments. So because Windows Defender Firewall with Advanced Security is a host-based firewall that is included with the operating system, there is no additional hardware or software required. Windows Firewall with Advanced Security is also designed to complement existing non-Microsoft network security solutions through a documented application programming interface, that is an API. Now, you can use Windows PowerShell to manage your firewall and IPsec deployments, and this object-oriented scripted environment, the PowerShell integrated scripted environment, makes it easier for you to manage policies and monitor network conditions than it would be possible with the other application command line which you can manage Windows Firewall with Advanced Security, and that is the netsh.exe. Now, Windows PowerShell, of course, allows network settings to be self-discoverable through the syntax and parameters in each of the commandlets. Now, you will have a link with additional details to an article called Windows Firewall with Advanced Security Administration with Windows PowerShell, which takes you through all the necessary details and commandlets that you need to manage the Windows Firewall with Advanced Security through PowerShell. Now, I have also included a resource file, a PDF, which you can download for this particular lesson, in which you will have available the most common networking commandlets used in PowerShell to basically administer the networking part of the operating system through PowerShell. Now, there are a number of ways that you can access the Windows Firewall with Advanced Security. First of all, using the user interface, you would click on Start, and basically, as you can see here, let me bring up the pen. You will click on Start and then type Windows Firewall with Advanced Security, or using a command prompt and then typing wf.msc, or using Windows PowerShell to manage your firewall and IPsec deployments. Now, although standard users can start Windows Firewall with Advanced Security, to change most settings, you must belong to the administrator group. So Windows Firewall with Advanced Security should be part of a comprehensive security solution that implements a variety of security technologies, such as perimeter firewalls, intrusion detection systems, virtual private networking or VPN, IEEE 802.1x authentication for wireless and wired communications, and IPsec connection security rules. Mapping your security design goals to Windows Firewall with Advanced Security deployment is an important step in a layered defense. Now, you will have a very comprehensive guide, a link to a very comprehensive guide in the downloadable resources called Windows Firewall with Advanced Security Design Guide, which I recommend that you go through and read. And basically it describes just this Windows Defender Firewall with Advanced Security deployment. Now, of course, you can use the guide's goal to deploy one of the Windows Firewall with Advanced Security designs, or a custom design that combines elements from those presented in the guide to match your security posture. In addition to descriptions and example for each design, you will also find in this guide guidelines for gathering the required data about your environment. You can use these guidelines to plan and design your Windows firewall with advanced security deployment. And after you read this guide and finish gathering, documenting, and mapping your organization requirements, you basically have the information that you need to deploy Windows firewall with advanced security using the guidance from this article. Okay, that being said, let's get into our next topic over here and talk about the virtual security mode. But before we do that, I just want to quickly show you how the Windows firewall with advanced security looks like. So I'm just going to open it over here. I'm going to drag it onto the screen. Here we go. This is what it looked like. Here you can configure inbound rules. This means the traffic that is getting from the outside of the network into this device. And here you can configure the outbound rules, meaning that what you allow from this device to go out to the internet. It is pretty simple to create a rule. You can just click on new rule. You can create a rule based on a program, based on a port, based on a predefined rule, and a custom rule as well. If I wanted to do a port rule for the inbound connection, and let's say I would specify port 80 here, then I would specify block the connection. I would select a profile to which this firewall rule would apply to. So if I leave all of these selected, it would apply regardless if I'm connected to a domain network, a private network, or a public network. Then give it a name and click OK. I'm not going to click OK, of course, because I've just created a firewall rule that would block all traffic coming in on port 80 from the outside. Okay, so that is just that simple. Let me cancel out of this and let's get back to the slides and on to our next topic. Now, since Microsoft cannot completely prevent malicious code from getting into the Windows kernel, a new security boundary was developed that helps to mitigate the aspect of kernel malware. This boundary is based on a Hyper-V hypervisor and a chip virtualization extension of the CPU, such as second level address translation, that is SLAT, and input-output memory management unit, IOMMU. And this is all to, let's say, wall off portions of the memory, right? Even the Windows kernel does not have access to this area. Virtual Secure Mode, or shortly VSM, works in the same way that two virtual machines on the same host cannot interact with each other. Their memory is independent and hardware regulated to ensure that each virtual machine can only access its own data. Virtual Secure Mode is the secure base that Credential Guard and Device Guard both use. Now, in this diagram here on the slide, you have an illustration of the relationship of the hypervisor with the installed operating system, usually referred to as the host operating system. Now, the difference between this and a traditional architecture is that the hypervisor sits directly on top of the hardware, rather than the host OS, that it would be Windows. Now, the hypervisor serves to abstract the host OS and any guest OS or processes from the underlying hardware itself, providing control and scheduling functions that allow the hardware to be shared. In Virtual Secure Mode, we are able to extend this by running specific processes. And before I get on, let's see here. This is the hypervisor. And as you can see, it's running right on top of the hardware here, just to clear this up. Now, again, in Virtual Secure Mode, we are able to extend this by running specific processes and their associated memory in a separate container, thus creating a secure area on top of the hypervisor where security-sensitive operations can occur. independent, of course, of the operating system. From here, we now have a protected mode where we can run security sensitive operations, and at the same time we can support capabilities that can reside here, like the local security authority LSA and code integrity control functions in the form of kernel mode code integrity, and of course the hypervisor code integrity control itself, which is called hypervisor code integrity, HVCI. Now, each of these processes that we've just mentioned are called trustlets, and they are illustrated in this diagram over here, right? So, because running LSA, for example, in VSM causes the LSA process itself to remain in the host OS, and a special edition of the LSA instance to that is called LSA ISO, which stands for LSA isolated, a separate instance is created. And this basically allows all the standard calls to LSA to still succeed, offering excellent legacy and backwards compatibility, even for the services or capabilities that require direct communication with LSA. Let me just change up the slide over here. And this is basically the components that are involved in the logon process. I'm talking about the logon process over here because if I just go back one slide, as you can see, this is again the hardware, the hypervisor. These are all the Windows apps that are running, and these are the trustlets. As you can see, a new process called isolated LSA, the LSA ISO, right? That is running separately, completely separated from the other apps. Okay? Now, let's talk about the components involved in the logon process. And the core components and databases that implement Windows security are shown in this particular picture from the slide. Sorry. So first of all, we have WinLogon, and we've discussed about this in a different course, but I'm going to do a refresh here, right? This is a user mode process for managing interactive sign-on. Then we have the logon UI over here, and this is a user mode process that presents the user with a sign-on interface, the one that you get when you are about to log into Windows, right? Then you have the LSASS, right? And the LSASS is all the one over here, right? This is a user mode process that is basically responsible for the local system security policy, user authentication, and sending security audit information to the event log. So all of these components over here, right, compose the LSASS. Then, with virtual secure mode, of course, as I've mentioned, you have the LSAISO over here. And this isolated local security authentication server is a special additional instance of LSA created in a virtual secure mode hypervisor, as I've just mentioned. Credential guard must be active for LSA ISO to exist. And this extra layer of security was introduced with Windows 10 and Windows Server 2016. Then you have the net logon, right? The net logon, and this is Windows service that creates a secure channel to a domain controller. Here we go. Let me point that out. This creates a secure channel to a domain controller. That security request is sent, for example, Active Directory logins. And then, last but not least, you have the SAM, right? And that is the Security Accounts Manager, which is responsible for managing the database that contains the usernames and groups stored on the local machine. And this is the SAM over here. Okay? So in Windows 10 version 1607 or later, uh, the isolated user mode, or this is another name for the virtual secure mode, basically is enabled by default. So virtual secure mode and the trustlets loaded within are controlled via either mobile device management or group policy. Okay, that is just how you manage these trustlets and settings of the virtual secure mode. And with that being said, guys, this concludes our discussion for this particular lesson. I will see you in the next one, where we'll basically be having a conversation in regards to credential guard and BitLocker. So, of course, I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track, Windows 10 Security Features. We are in section 4 of the course, and in this lesson we are going to discuss about Credential Guard and BitLocker. And more specifically, we're going to have an overview of Credential Guard. We're going to see how does Credential Guard work, then a BitLocker overview, what is BitLocker and so on, and BitLocker new features. That being said, let's get into our first topic here. So, introduced in Windows 10 Enterprise and Windows Server 2016, Credential Guard uses virtualization-based security to isolate secrets so that only privileged system software can access them. Unauthorized access to the secrets can lead to credential theft attacks such as pass the hash or pass the ticket techniques that we've discussed in a previous course. Credential Guard prevents these attacks by protecting the NTLM password hashes, Kerberos ticket granting tickets, and credentials stored by applications as domain credentials. Credential Guard supports the following features and solutions. And let me just bring up my pen over here. Hardware security. So hardware security, the first one over here, NTLM, Kerberos, and Credential Manager take advantage of platform security features, including the secure boot and virtualization to protect the credentials. Then it takes advantage, it has another feature, and that is virtualization-based security. So Windows NTLM and Kerberos derived credentials and other secrets run in a protected environment that is isolated from the running operating system. And that is a big plus, because the credentials are in this way protected, even from the operating system itself. And then we have better protection against persistent threats, advanced persistent threats. When Credential Manager domain credentials, NTLM, and Kerberos derived credentials are protecting using virtualization-based security, the credential theft attack techniques and tools, of course, used to many targeted attacks are actually blocked. So malware running in the operating system with administrative privileges cannot extract secrets that are protected by virtualization-based security. While Credential Guard is a powerful mitigation persistent threat attacks, will likely to shift to new attack techniques, and you would also need to incorporate device guard and other security strategies and architectures to be able to, let's say, fully protect a device running Windows 10 operating system. Now, if Credential Guard is not enabled by default, and it can be enabled by configuring the virtual secure mode and virtualization-based security group policy setting with Credential Guard configured to enable, and these are the settings over here. So as you can see, Device Guard Security Services configured Credential Guard, and Device Guard Security Services running Credential Guard again. Okay, now let's see how does Credential guard work. So Kerberos NTLM and Credential Manager isolate secrets by using virtualization-based security. Previous versions of Windows stored secrets in the local security authority, and that is the LSA. Prior to Windows 10, the LSA stored secrets used by the operating system in its process memory. With Credential Guard enabled, the LSA process in the operating system talks to a new component called the isolated LSA process that actually stores and protects those secrets. Data stored by the isolated LSA process is protected by using virtualization-based security and is not accessible to the rest of the operating system. LSA uses remote procedure calls to communicate with the isolated LSA process. Now, for security reasons, the isolated LSA process doesn't host any device drivers. Instead, it only hosts a small subset of operating system binaries that are needed for security and nothing else. These binaries are signed with a certificate that is trusted by virtualization-based security, and these signatures are validated before launching the file in the protected environment. When Credential Guard is enabled, NTLM version 1, MS-CHEP version 2, Digest, and CRED SSP cannot use the sign-in credentials. Thus, single sign-on does not work with these protocols. However, applications can prompt for credentials or use credentials stored in the Windows Vault, which are not protected by Credential Guard with any of these protocols. If the protocols must be used by the domain or Azure AD users, secondary credentials should be provisioned for these use cases. So when Credential Guard is enabled again, Kerberos does not allow unconstrained Kerberos delegation or DES encryption, which is a positive effect not only for signed-in credentials, but also prompted or saved credential. Now, over here on the slide, you have a high-level overview of how the LSA is isolated by using virtualization-based security. As you can see, the LSASS process runs over here, and when Credential Guard is enabled, another process is created that runs in isolation, and that is the LSA ISO. Now, to have a complete understanding of the Credential Guard and how does it work, I've left a link into the downloadable resources for this lesson, which is basically a blog, an article called Deep Dive into Credential Guard, and which I highly recommend for you guys to go through. And that being said, we will go into our next topic over here, and we will talk about BitLocker. So let me just change the slide, and here we go. So the best type of security measures is transparent to the user during the implementation and use. Every time there is a possible delay or difficulty because of a security feature, there is a strong likelihood that users will try to bypass that security feature. This situation is especially true for data protection, and that's a scenario that organizations need to avoid. Encryption basically is the process of encoding message or information such that only authorized parties can read it. In general, encryption should be used for all data, whether it is at rest or in transit. Whether you're planning to encrypt entire volumes, removable devices, or individual files, Windows 10 will meet these needs by providing streamlined, usable solutions. BitLocker drive encryption is basically a data protection feature that integrates with the operating system and addresses the threats of data theft or exposure from lost, stolen, or inappropriately decommissioned computers. BitLocker provides the most protection when used with a trusted platform module, a TPM, version 1.2 or later. The TPM, again, we've discussed about this, is a hardware component installed by computer manufacturers in most modern computers. It works with BitLocker to help protect user data and to ensure that a computer has not been tampered with while the system was offline. On computers that do not have a TPM version 1.2 or later, you can still use BitLocker to encrypt the Windows operating system drive. However, this implementation requires that you insert a USB startup key to start the computer or resume from hibernation. Starting with Windows 8, you can use an operating system volume password to protect the operating system volume on a computer without TPM. Both options do not provide the pre-startup system integrity verification offered by BitLocker with a TPM. In addition to the TPM, BitLocker offers the option to lock the normal startup process until the user supplies a personal identification number, a PIN, or inserts a removable device such as a USB flash drive that contains the startup key. These additional security measures provide multi-factor authentication and assurance that the computer will not start or resume from hibernation until the correct PIN or startup key is presented. Now, don't worry, you will have a hands-on lab at the end of the course in which you will get to experience hands-on working with BitLocker, implementing BitLocker, and so on. So now, let's talk about the BitLocker new features that came along with the Windows 10 anniversary release. And some of these features are the following. First of all, the first one on the slide here that you can see, and let me just point it out, is the XTS AES encryption algorithm. So BitLocker now supports the XTS AES encryption algorithm. This algorithm provides additional protection from a class of attacks on encryption that rely on manipulating ciphertext to cause predictable changes in plain text. These predictable changes offer clues to actually be able to decrypt the ciphertext. BitLocker supports both 128-bit and the 256-bit XTS AES keys. Now, this basically provides the following additional benefits. So, the algorithm is United States Federal Information Processing Standards compliant, that is FIPS. It is easier to administer, and you can use the BitLocker wizard command line to administer this. You can also use the manage BDE command line utility. You can use the group policy. You can use MDM policy, Windows PowerShell, or WMI to manage it on devices in your organization. This is the part over here. And the drives encrypted with XTS AES will not be accessible on older versions of Windows. And this is the one over here. So this is only recommended for fixed and operating system drives. Removable drives should continue to use the AES CBC 128-bit or AES CBC 256-bit algorithms. Don't worry, you will have links in the downloadable resources for this lesson, which will take you into a deep dive in regards to this algorithms, this encryption algorithms, and you can have additional reading regarding this. Now, another benefit of a new feature of BitLocker is that you can encrypt and recover your device with Azure Active Directory. Here is the feature. So in addition to using a Microsoft account, Automatic device encryption can now encrypt your devices that are joined to an Azure Active Directory domain. When the device is encrypted, the BitLocker recovery key is automatically escrowed to the Azure Active Directory. This will make it easier to recover your BitLocker key while being online. Then you have the DMA port protection. So you can use the data protection allow direct memory access MDM policy, which you can find in Intune, now called Microsoft Endpoint Manager. And you can use this policy to block DMA ports when the device is starting up. Also, when a device is locked, all unused DMA ports are turned off, but any devices that are already plugged into a DMA port will continue to work. When the device is unlocked, of course, all DMA ports are turned back on. Then you have new group policy settings. So you have new group policy for configuring pre-boot recovery. You can now configure the pre-boot recovery message and recover URL that is shown on the pre-boot recovery screen. Then you have network unlock. And this basically allows PCs to start automatically when connected to the internal network. Then the BitLock protector. BitLock supports a protector tied to a user or computer AD account or group. Now, you can use the managebde.exe to check out these settings and this protector settings, and by using this protector, only users specified by the account or belonging to the group specified, or a computer, of course, account belonging to a computer group, can unlock the volume for any kind of access, read or write. Unlock attempts happen automatically on user logon or device insertion. Thus, if a user or a computer is authorized, they will get access to the drive. Now, this BitLocker feature does not have, let's say, a granularity of providing just read-only access to unauthorized devices or users. Then you have a new feature that basically it's about no longer supporting a PIN, no longer requiring a PIN. So modern Windows devices no longer require a PIN in the pre-boot environment to protect BitLocker encryption keys from cold boot attacks. Users who have standard privileges can change their BitLocker PIN or password on legacy devices that still require a PIN. Then you have the BitLocker provisioning over here. So BitLocker pre-provisioning, encrypting hard drives and used space-only encryption basically allow administrators to enable BitLocker quickly on new computers. We have offloading of the encryption. So BitLocker supports offloading encryption to encrypt hard drives. Then we have used space only. So used space only encryption in BitLocker to go allows users to encrypt drives in literally just seconds. And then, last but not least, BitLocker requires the user to enter a recovery key only when disk corruption occurs or when he or she loses the PIN or password. Modern devices are increasingly protected with device encryption out of the box and support single sign-on to help protect the BitLocker encryption keys from cold boot attacks. Administrators can manage domain joined devices that have device encryption enabled through the Microsoft BitLocker administration and monitoring tool, that is the shortly called MBAM. So MBAM. In this case, device encryption automatically makes additional BitLocker options available. No conversion or encryption is required, and MBAM can manage the full BitLocker policy set if any configuration changes are required. Part of the Microsoft Desktop Optimization Pack, MBAM makes it easier to manage and support BitLocker and BitLocker to go. MBAM 2.5 with Service Pack 1 is the latest version. For more information on MBAM, please see the downloadable resources for this lesson, in which you will find a link with a deep dive on this particular topic. And that being said, this concludes our discussion for this particular lesson. I will see everyone in the next lesson, where we'll discuss about the default antivirus on the Windows 10 operating system, that is the Windows Defender antivirus, and about Windows information protection. So I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Pro track called Windows 10 Security Features. We are in section 5 of the course, and in this one we are going to discuss about the Windows 10 security features part 2, and mainly the Windows 10 software security features as additional features. And as lessons we have here Windows Defender Remote Credential Guard. Then the next lesson we are going to discuss about Device Guard, then UpLocker with Device Guard, and Windows Defender Smart Screen and Windows 10 Telemetry. So, as I said, in this first lesson we are going to have a high-level detailed overview about Windows Defender Remote Credential Guard, and specifically we are going to see what Windows Defender Remote Credential Guard is, why use Remote Credential Guard, hardware and software requirements, considerations when using Remote Credential Guard. So that being said, let's get into our first topic over here and have an overview of Remote Credential Guard. So, introduced in Windows 10 version 16.07, Remote Credential Guard, now called Windows Defender Remote Credential Guard, helps you basically protect your credentials over a remote desktop connection by redirecting the Kerberos requests back to the device that's requesting the connection. It also provides single sign-on experiences for remote desktop sessions. If the target device is compromised, your credentials are not exposed because both credential and credential derivatives are never sent to the target device. Now, you can basically use Remote Credential Guard in the following ways. Administrator credentials, basically, which are highly privileged and must be protected. So by using Remote Credential Guard to connect, you can be assured that your credentials are not passed over the network to the target device. And a next use case scenario for example, for help desk employees in your organization that must connect to the domain joined devices that could be compromised. So with Remote Credential Guard, the help desk employees can use RDP to connect to the target device without compromising their credentials to malware that may possibly be on one of the domain joined devices. Now, let's talk about the hardware and software requirements of Windows Defender Remote Credential Guard, and let me bring up my pen over here. So the remote desktop client and server must meet the following requirements to use Remote Credential Guard. First of all, they have to be joined to an Active Directory domain, and that probably is pretty straightforward, and you can't use without this requirement. Then the next one is that the one over here, both devices must either be joined to the same domain, or the remote desktop server must be joined to a domain with a trust relationship to the client device's domain. So if the client device is in one domain and the remote desktop server is in another domain, a trust relationship must exist between the two domains for you to be able to use Remote Credential Guard. Now, the next one is that both must use Kerberos for authentication. And given the fact that the first requirement is that both the server and the clients must be joined to an Active Directory domain. Using Kerberos, I would say that it comes by default. Then, another important requirement is that they must be running, both the client and the server must be running at least Windows 10 version 16.07 or Windows Server 2016. And the last one from our list here, the last requirement, is that the Remote Desktop Classic Windows app is required. So the Remote Desktop Universal Windows Platform app doesn't support Remote Credential Guard. Now, let's talk about some considerations that you may want to be aware of when using Remote Credential Guard. So first of all, the Remote Credential Guard does not support and does not include device claims. And device claims are basically ways to audit attributes in the computer's account in Active Directory. You will have a link to additional reading in regards to what is device claims and how it can be used in the downloadable resources for this particular lesson. So it does not include device claims. For example, if you're trying to access a file server from the remote system and the file server requires a device claim, access will be denied. Then the next one is that Remote Credential Guard cannot be used to connect to a device that is joined to Azure Active Directory. And I would say this is a pretty important one. Then no credentials, then the RDP, the Remote Desktop Credential Guard, only works with RDP, and that is by default over here, right? So it only works with the RDP protocol and with no other remote connection, let's say, protocol. One other thing to consider is that the credentials no credentials are sent to the target device, but the target device still acquires the Kerberos service tickets on its own. Then the remote desktop gateway is not again compatible with Remote Credential Guard, and this is the consideration over here. The remote desktop gateway, and again, you will have links about the remote desktop gateway for additional reading in the downloadable resources for this lesson. The other one is that you can not use saved credentials or credentials that are different than yours. So you must use the credentials of the user who is logged in to the device when using Remote Credential Guard to connect via RDP to another device. Then another one is that both the client and the server must be joined to the same domain or to the domains that have an existing trust relationship between them. And of course, as we've mentioned earlier, the server and the client must authenticate using Kerberos. Now, that pretty much concludes the discussion for this particular lesson. One other thing I want to say is that basically when using Remote Credential Guard, and you will have the opportunity to actually use this, test this in the labs that are available at the end of the course. And again, this concludes our lesson. I will see everyone in the next lesson, of course, where we'll discuss about another security feature of Windows 10, and that is the device guard. So I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track, Windows 10 Security Features. We are in section 5, and this is the second lesson of the section in which we are going to discuss about device guard. And specifically, we are going to talk about the requirements for device guard, about the code integrity components, about how device guard help protect against threats, and of course, tools to manage device guard. First of all, device guard, or shortly DG, is a combination of enterprise-related hardware and software security features that, when configured together, will lock a device down so that it can only run trusted applications that you define in your code integrity policies. Running Device Guard on Windows 10 Enterprise changes the system from a mode where apps are trusted unless blocked by an antivirus or other security solution to a mode where the operating system trusts only apps that are authorized by your enterprise. So you designate these trusted apps by creating code integrity policies, and we'll discuss about them in a moment. But first of all, let's take a moment and take a look at what are the requirements to use Device Guard. First of all, you will need a 64-bit version of Windows Enterprise or Windows 10 Education. You will also need UEFI 2.3.1 or later. You will need Secure Boot, enabled of course. You will need the virtualization features that are listed over here, and let me just bring up my pen. So Intel VTX, AMD/V, and SLAT must be enabled, right? You will also have links, of course, to additional reading in regards to all of these technologies in the downloadable resources for this particular lesson. Then another requirement would be that VT or AMD VI input-output memory management unit must be in place. And again, you will also have links to documentation in regards to these technologies. And the last but not the least requirement here is that you would need a TPM. So Windows 10 version 15.11 supports both TPM 1.2 and TPM 2.0, but earlier versions of Windows 10 support only TPM 2.0. And the last requirement, of course, you will need firmware lock. So that being said, let's get on to our next topic and talk about the code integrity components. Because, like the operating system, code integrity components contains two primary components. And these are kernel mode code integrity and user mode code integrity. And shortly, it's KMCI and UMCI. Let's talk about first about kernel mode code integrity, KMCI. So KMCI has been available in previous versions of the Windows operating system and basically protects the kernel mode from running unsigned drivers. In Windows 10 and Windows Server 2016, user mode code integrity is also available to help protect against viruses and malware. Now, to increase the security level offered by code integrity policies, Device Guard can leverage advanced hardware features on hardware that supports them. These features include CPU virtualization extensions. They are called Intel VTX or AMD V. And, of course, they also support second-level address translation, and that is SLAT. In addition, hardware that includes input-output memory management units provides even stronger protections. When you enable the features associated with CPU virtualization extensions and second-level address translation, SLAT, the code integrity service can run alongside the kernel in a Windows hypervisor protected container. Device Guard configurable code integrity policies can be deployed on most systems even without hardware virtualization support. The system is not as secure if secure boot is not available, and therefore virtualization-based security, which we've discussed in a previous lesson, which depends on secure boot, is not available as well, but it still works. Since Windows 10, all client machines should have secure boot, and most enterprise class machines should also have virtualization, but in many cases virtualization based security will be something to be enabled on newer devices as they are deployed. Now let's talk about our last point over here, and then one more thing I want to mention, that Microsoft provides a collection of PowerShell scripts to see if your hardware is ready for Device Guard and Credential Guard. The scripts can also, of course, enable Device Guard and Credential Guard, and you will find a link which takes you to a page where you can actually download and check out these scripts that I'm talking about in the documentation files as downloadable resources for this lesson. Now, one more thing that Device Guard does is that let me just point the arrow here, it leverages virtualization-based security, VBS, to isolate its hypervisor code integrity service, which enables Device Guard to help protect the kernel mode processes and drivers from vulnerability exploits and 0 days. Now, hypervisor code integrity uses the processor's functionality to force all software running in kernel mode to safely allocate memory. This means that after memory has been allocated, its state must be changed from writable to read-only or execute-only. By forcing memory into these states, it helps ensure that attacks are unable to inject malicious code into kernel mode processes and drivers, of course, through techniques such as buffer overruns, buffer overflows, or heap spraying. Now let's talk about the user mode code integrity, and here it's pretty simple. User mode code integrity can use UMCI and ACG, that is arbitrary code guard, to achieve similar levels of protection, although these protection assume that the kernel has not been compromised to be effective. So let's take a look at how Device Guard helps protect against threats, and let me bring up the other slide. So in the following table over here from the slide, we have basically the table lists security threats and describes the corresponding Device Guard features which help mitigate against them. So I would advise you to please take a moment and go through this table. For example, this is the security threat, exposure to new malware for which the signature is not yet known, also known as a 0-day. And over here, you have an explanation of how Device Guard feature can help protect you against this type of threat. Of course, please go ahead and have a read through the slide. You will also have a link available in the documentation files as downloadable resources for this lesson, which takes you to, let's say, a more detailed version of this table, so you can have a more deep look at it, let's say. That being said, let me change the slide over here, and let's talk about the tools that can be used to manage Device Guard. So Device Guard can easily be managed by enterprise and client management tools that you probably already use in your every day-to-day business, right? And this is, first of all, it can be managed through group policy. So Windows 10 provides an administrative template to configure and deploy the configurable code integrity policies for your organization. And this template also allows you to specify which hardware-based security features you would like to enable and deploy. You can manage these settings along with your existing group policy objects, which basically makes it simpler to implement Device Guard features. In addition to these code integrity and hardware-based security features, you can use group policy to deploy and to help you manage your catalog files. Don't worry, again, you'll have labs available at the end of the course in which you will get to play with this, you will get to deploy this, you will get to experience this hands-on, right? Then, you can also manage Device Guard through System Center Configuration Manager. and that is SCCM. So you can use System Center Configuration Manager to simplify deployment and management of catalog files, code integrity policies, and hardware-based security features, as well as provide version control. You will also have a link available in the downloadable resources for this lesson, sorry, which will take you to a more detailed guide about about managing device guard with System Center Configuration Manager. And lastly here, of course, you can use Microsoft Intune or newly called Microsoft Unified Endpoint Manager to manage device guard. And of course, again, you will also have links which will take you to additional reading in regards to managing device guard with Microsoft Endpoint Manager / Microsoft Intune. Now, if you want to check out more details, you will have some additional links to additional reading, which take you to, let's say, deeper details in regards to this that are out of our scope of this particular course. But of course, if you're interested, please go ahead and have a read through the files. The first one, basically, the first link which you'll find is the deployment and planning guidelines for device guard. Then you'll find a link to an article which basically is called Deploy Device Guard and Enable Virtualization-Based Security. And of course, you'll also have a link to Microsoft Virtual Academy, which basically takes you to a in-depth free course in regards to device guard called Dropping the Hammer on Malware with Windows 10 Device Guard. That being said, guys, this concludes the discussion for this particular lesson. And of course, I will see everyone in the next one, where we'll talk about another topic kind of related to device guard, and that is App Locker with Device Guard. So I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track called Windows 10 Security Features. We are in section 5 of the course, and in this lesson we are going to discuss about App Locker with Device Guard. And more specifically, we're going to have an App Locker overview, scenarios for App Locker that App Locker addresses, and when to use App Locker. So that being said, let's hop into our first topic over here and talk about App Locker itself. So App Locker, in conjunction with Device Guard, can provide a finer grain application control policies. App Locker helps you basically control which apps and files users can run, and these include executable files, scripts, Windows installer files, DLLs, dynamic link libraries, packaged app files, and packaged app installers. Now, although App Locker is not considered a new Device Guard feature, it complements Device Guard functionality when enforced code integrity cannot be fully implemented, or when its functionality does not cover every desired scenario. There are many scenarios in which code integrity policies would be used alongside App Locker rules. As a best practice, you should enforce code integrity policies at the most restrictive level possible for your organization, and then you can use App Locker to fine-tune the restrictions to an even lower level. Now, let's see what App Locker can help you with. So first of all, you can define rules based on file attributes that persist across app updates. And this is the one over here. And these are such as, let's say, the publisher name that is derived from the digital signature. You can specify, you can define rules based on product name, based on file name, or even based on file version. And of course, you can also create rules based on the file path or the file hash. And these rules you can create them to allow a specific file or to deny a specific file. Then you can assign a rule to a security group or to an individual user. You can also create exceptions to rules, and for example, you can create a rule that allows all users to run all Windows binaries except the registry editor, for example, right? You can use audit only mode to actually deploy the policy and understand what impact it has before enforcing the policy. You can also create rules on a staging server, and this is for you to be able to create the rules, test them, and then import them into your production environment and import them into a group policy object. And last but not least, you can simplify creating and managing AppLocker rules by, of course, using Windows PowerShell. Again, AppLocker basically helps to reduce the administrative overhead and helps to reduce the organization's cost of managing computing resources by decreasing the number of help desk calls, for example, uh, result from users running unapproved applications. AppLocker should address the following security scenarios. First of all, application inventory. So AppLocker can enforce its policy in audit-only mode, where all app access activity is registered in the event logs. These events can be collected for further analysis, and there are Windows PowerShell commandlets available to also help you to analyze this data programmatically. Then you have protection against unwanted software. So AppLocker, of course, can deny applications from running when you exclude them from the list of allowed apps. When AppLocker rules are enforced in the production environment, any apps that are not specifically included in the allowed rules, are blocked from running. Then you have licensing conformance, right? AppLocker can help you create rules that preclude unlicensed software from running and restrict licensed software to authorized users only. Then you would also be helped by AppLocker with software standardization, because AppLocker policies can be configured to allow only supported or approved apps to run on computers within a business group, and this permits basically uniform app deployment. And again, last but not least, you have manageability improvement. So AppLocker includes a number of improvements in manageability as compared to its predecessor, software restriction policies. And for this, for example, importing and exporting policies, automatic generation of rules for multiple files, audit-only mode deployment, and Windows PowerShell commandlets, of course, which I have mentioned before, are just a few of the improvements made to AppLocker over software restriction policies. Now, let's talk about when to actually use AppLocker. So, in many organizations, information is one of the most valuable assets, and ensuring that only approved users have access to that information is imperative. Access control technologies such as Windows Information Protection and Access Control List help control what users can access. However, when a user runs a process, that process has the same level of access to data that the user has. As a result, sensitive information could be easily deleted or transmitted out of the organization if a user knowingly or unknowingly runs any kind of malicious software. So AppLocker can help mitigate these types of security breaches by restricting the files that users or groups can run. So, for example, software publishers are beginning to create more apps that can be installed by non-administrative users. So this could jeopardize an organization's written security policy and circumvent traditional app control solutions that actually rely on the inability of the users to install apps. By creating an allow list of approved apps and files, of course, sometimes what is called a whitelist. App Locker helps prevent such per-user apps from running. Because App Locker can control DLLs, it is also useful to control who can install and run ActiveX controls, for example, right? So App Locker is ideal for organizations that currently use group policy to manage their PCs. These here on the slides are just some examples of scenarios in which App Locker can be used. So one of them would be if your organization's security policy dictates the use of only licensed software. So you need to prevent users from running unlicensed software and also restrict the use of licensed software to authorized users only. Then the next scenario would be if an app is no longer supported by your organization. You would just remove it from the whitelist, and the app will no longer be preventing from being used by everyone in the organization. Then the potential that unwanted software can be introduced into your environment is high. So basically, you need to reduce that threat, and you can use AppLocker to do this. Another scenario would be if the license to an app has been revoked or it is expired in your organization, and you need to prevent it from being used again by everyone, and you would be able to do that with AppLocker. Another scenario would be if a new app or a new version of an app is been deployed, and you need to prevent users from running the old version of the app. You would do that again with AppLocker. Another scenario where you have specific software tools that are not allowed within organization, or only specific users should have access to those tools. Again, you can accomplish that with AppLocker. Then, if a single user or a small group of users needs to use a specific app that is denied for all other users, you would be able to allow that app to be run only by those specific users. Now, in addition, again, in addition to other measures, you would need to control access to sensitive data through app usage. And another scenario would be if some computers in your organization are shared by people who have different software usage needs, and you need to protect those specific apps. Now, application control policies specify which apps are allowed to run on a computer, right? The variety of forms that, let's say, malicious software can take, it is difficult for users to know what is safe to be run and what is not safe. So when activated, malicious software can damage content on a hard drive, can flood the network with requests that cause a denial of service attack, or can send confidential information to the internet or compromise the security of a computer. Now, the countermeasure here is to create a sound design for your application control policies on your PCs in your organization, and then thoroughly test the policies in a lab environment before you deploy them into production environment. AppLocker can be a part of your application control strategy because you can control what software is allowed to run on your computers. Now, a flawed application control policy implementation can actually disable the necessary applications or allow malicious unwanted software to run. Therefore, it is very important that organizations dictate sufficient resources to manage and troubleshoot the implementation of such policies. For additional information about specific security issues, you will have a link in the documentation file downloadable for this particular lesson called Security Considerations for AppLocker. So please have a look through it. And again, AppLocker can help you protect the digital assets in your organization, reduce the threats of malicious software being introduced in the environment, and improve the management of application control and the maintenance of application control policies. Other two very, very useful links that you will also find in the downloadable resources for this lesson in the documentation file are two links, one of them called Administer AppLocker and the other one AppLocker Technical Reference, which I again strongly recommend that you go ahead and have a read through, because they are great resources and get into more deep details in regards to AppLocker, which are out of the scope of this course. And as a conclusion here, in fact, let me just quickly show you, just one second. Let me just quickly show you where you will find AppLocker, just to have an idea. So I've just opened a group policy editor, a local group policy editor here on my computer, and if I just expand here, computer configuration, Windows settings, security settings, then we would need to look to application control policies. Here is where you'll find everything you can and want to configure in regards to AppLocker. As you can see, you have packaged app rules, script rules, Windows installer rules, executable rules, and AppLocker itself, where if you want to deploy AppLocker, this is where you'll create the first default application list, and so on. But again, have a read through the documentation which I've left in the downloadable resources, because you'll find more details over there. So let me close this one down. And as a conclusion here, AppLocker and Device Guard should run side by side in your organization, which basically offers the best of both security features at the same time and provides the most comprehensive security to as many devices as possible. In addition to these features, it is also recommended that you continue to maintain an enterprise antivirus solution for a well-rounded security portfolio. Now, this being said, we have concluded the discussion for this lesson. I will see everyone in the next lesson, where we'll discuss about Windows Defender Smart Screen and Windows 10 levels of telemetry. So I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track called Windows 10 Security Features. We are in section 5, and this is the last lesson of this section, in which we are going to discuss about Windows Defender Smart Screen and Windows 10 telemetry. More specifically, we are going to have an overview of Windows Defender Smart Screen, the benefits of Windows Defender Smart Screen, how to report unsafe websites. Then we are going to get into Windows 10 telemetry, some examples of Windows 10 telemetry data, and the telemetry levels. So first of all, if you are familiar with Windows Smart Screen before Windows 10, version 17.03, this feature was called Windows Smart Screen when used outside of the browser, and the Smart Screen filter when used within the browser. Windows Defender Smart Screen, or shortly called WDSS, helps protect your employees if they try to visit sites previously reported as phishing or malware websites, or if an employee tries to download a potentially malicious file. Now, Windows Defender Smart Screen determines if a site is malicious by using the following two methods. So first of all, let me bring up the pen. The first one is analyzing visited web pages, looking for indicators of suspicious behavior. If it finds suspicious pages, Smart Screen shows a warning message advising caution. The second method, and this one is over here, is by checking the visited website against a dynamic list of reported phishing sites and malicious software sites. If it finds a match, Smart Screen shows a warning to let the user know that the site might be malicious. Now, Windows Defender Smart Screen basically helps to provide an early warning system against a website or websites that might engage in phishing attacks or attempts to distribute malware through a socially engineered attack. The primary benefits of the Windows Defender Smart Screen are anti-phishing and anti-malware support. So Smart Screen helps protect your employees from sites that are reported to host phishing attacks or attempt to distribute malicious software. It can also help protect against deceptive advertisements, scam sites, or drive-by attacks. Now, drive-by attacks are, let's say, web-based attacks that tend to start on a trusted site, targeting security vulnerabilities in commonly used software. And I have a visual representation here of a drive-by attack and what would be the flow and how it would look like. Now, because drive-by attacks can happen even if the user does not click or download anything from the web page, the danger often goes unnoticed. Often, drive-by attacks make use of services known as exploit kits, and of course, again, you will find a link in the downloadable resources to that take you to documentation in regards to what is an exploit kit and more details in regards to them. So, drive-by attacks make use of these services known as exploit kits to scale effectively. These are basically tools that first check your PC for software vulnerabilities and then try to exploit them. These kits can use exploits targeting a variety of software, including Adobe Flash Player, Adobe Reader, Internet Explorer, Oracle, Java, or Sun Java, and the list goes on. Now, this graphic below again shows how an exploit kit might attempt to exploit your PC when you visit a compromised web page. The most common method used by attackers to distribute exploits and exploit kits is through web pages, of course, but these can also arrive in emails. Some legitimate websites unknowingly and unwillingly host malicious code and exploits in their ads. Microsoft and Windows 10 now extended the Smart Screen capability to include protection from drive-by attacks in Microsoft Edge and in the previous version of Internet Explorer 11. Now let's get back over here to our list. So we've discussed about the first one, the anti-phishing and anti-malware support. We've discussed about the drive-by attacks. The next one on the list of benefits of Windows Defender Smart Screen is reputation-based URL and app reputation. Now, Smart Screen evaluates a website's URL to determine if they're known to distribute or host unsafe content. It also provides reputation checks for apps, checking downloaded programs, and the digital signature used to sign a file. If a URL, a file, an app, or a certificate has an established reputation, your employees won't see any kind of warnings. If, however, there's no reputation, the item is marked as a higher risk and presents a warning to the employee. Then you have operating system integration, right? And Smart Screen is integrated into the Windows 10 operating system, meaning that it checks any files and app or including third-party browsers and email clients attempts to download and run. Then you have improved heuristic and telemetry, and here Smart Screen is constantly learning and endeavoring to stay up to date so it can help to protect you against potentially malicious sites and files. And then you have the management capability through Group Policy and Microsoft Intune, newly renamed to Microsoft Endpoint Manager. So Smart Screen again supports using both Group Policy and Microsoft Endpoint Manager policies settings to help you manage your organization's computer's settings. Based on how you set up Windows Defender Smart Screen, you can show employees a warning page and let them continue to the site, or you can entirely block the site. Smart Screen uses registry-based administrative template policy settings. Again, you will have a link to a site that provides links to the latest technical documentation, videos, and downloads for Group Policy, as well as for Microsoft Intune, Microsoft Endpoint Manager, mobile device management policy settings. Now, additionally, if you find a site that you think it is unsafe, you can also report it to Microsoft by using either Microsoft Edge on Windows 10 or Internet Explorer on Windows 10. That is Internet Explorer version 11. To report a website using Microsoft Edge, you would just click the More menu, choose Send Feedback, and then choose to report the website as unsafe. In fact, let me just open up Edge over here, and I am going to show you exactly. So you would click on here, you would find the help and feedback and report the website as unsafe, right? This would be the link that you would click. Let me close down Edge and let's get back to our slides. And that being said, let's also get into our next topic over here and talk about the Windows 10 telemetry. So Windows 10 telemetry is basically a vital technical data from Windows devices about the device and how Windows and related software are performing. The release cadence of Windows 10 may be fast, so feedback is critical to its success, right? So basically, they rely on telemetry at each stage of the process to inform Microsoft's decision and prioritize their efforts. Now, telemetry is used in the following ways: to keep Windows up to date, to keep Windows secure, reliable, and performant, to improve Windows through the aggregate analysis of the use of Windows, of course, and to personalize Windows engagement surfaces. Now, let me just change the slide over here, and here are some specific examples of Windows 10 telemetry data. The first one, for example, being type of hardware being used, or applications that are installed and their usage details, or reliability information on the device drivers, right? So telemetry can sometimes, let's say, be confused with functional data. Some Windows components and apps connect to Microsoft services directly, but the data they exchange is not actually telemetry. So for example, exchanging a user's location for your local weather or news, it is not an example of telemetry. It is just functional data that the app or service requires to satisfy the user's request. And that is what I wanted to mention, because I don't want you to have any confusion in regards to the telemetry and the functional data, which is a different kind of thing that computers send to Microsoft. Now, there are different telemetry levels in Windows 10, in Windows Server 2016, and or in System Center, for example, right? These levels are available on all desktop and mobile editions of Windows 10, except for the security level, which is limited to Windows 10 Enterprise, Windows 10 Education, Windows 10 Mobile Enterprise, and Windows 10 IoT Core. And of course, Windows Server 2016. Now, the telemetry data is categorized in 4 main levels, and these are the ones over here. So security, basic, enhanced, and full. And let me just say a few words about each and one of them. So the first one is security, right? So this is information that's required to help keep Windows Server, and System Center secure, including data about the connected user experience and telemetry component settings, the malicious software removal tools, and Windows Defender. This level is only available on Windows Server 2016, Windows 10 Enterprise, as I've mentioned, Windows 10 Education, Mobile Enterprise, and Windows IoT Core Edition. The basic level, this is basic device info, including quality-related data, app compatibility, app usage data, and data from the security level. Then you have the enhanced telemetry level, and this includes additional insights like how Windows or Windows Server or System Center and apps are used, how they perform, advanced reliability data, and of course data from both the basic and the security levels. And then you have the full telemetry level, and this basically is all data necessary to identify and help to fix problems, plus the data from the security, basic, and enhanced levels. You have the levels, basically the levels are cumulative, and again you have them illustrated in the diagram here on the right hand side of the slide, and also these levels apply to all editions of Windows Server 2016. Now, in the downloadable resources for this particular lesson, you will find a link which takes you to more details and additional details in regards to each kind of data gathered and at each level that we've just spoke about. The article is called, and the link is called, Configure Windows Telemetry in Your Organization. Please have a read through it because it's very, very useful. Now, when deciding on the telemetry, on the level of telemetry data allowed to be gathered and shared by Microsoft, it is important that you understand Microsoft's privacy principles. So, basically Microsoft earned customer trust every day by focusing on 6 key privacy principles described in a link which you'll find in the downloadable resources, privacy.microsoft.com, right? These principles guided the implementation of the Windows telemetry system. These telemetry levels only apply to Windows, again, Windows Server and System Center components and apps that use the connected user experience and telemetry component. Non-Windows components, such as Microsoft Office or other third-party apps, may communicate with their own cloud services outside of these telemetry levels. So again, if you want to implement this, you should work with your app vendors to understand their telemetry policies and how you can opt in or opt out of this. Again, you will find more information in the downloadable resources for this file, in the documentation file for this lesson, in a very, very cool article called Overview of Office Telemetry, which probably you already realized, as the name tells, gives you more information and details in regards to Microsoft Office users and how Microsoft Office uses telemetry. So that being said, this concludes the discussion for this lesson and for this section as well. Of course, I will see everyone in the next section, where we'll discuss about Windows 10 new security features and capabilities, and we'll also end the course with a very nice case study in regards to ransomware. So, of course, I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track, Windows 10 security features. We are in section 6. This is the last section of the course, and in this section we are going to discuss about Windows 10 new security features and capabilities. We'll have 3 lessons in this section. In the first one, we are going to talk about Windows Hello and Hello for Business. Then we are going to discuss about other security features and capability. And lastly, we are going to talk about and actually take a look at a ransomware case study. So this first lesson here will discuss about Windows Hello and Hello for Business. And more specifically, I want to first discuss about Windows 10 Creators Update, which I think it's worth mentioning because even though it was released back in 2017, it brought important improvements from a security perspective to the operating systems. Then we are going to talk about Windows Hello, then about authentication, Windows Hello for Business, the update to Windows Hello for Business. Then we are going to discuss about the PIN versus the password, managing Windows Hello, and of course Windows Hello deployment options. So as I said, let's have just a few words on the Windows 10 Creators Update, because Even though it was released back in 2017, it delivered lots of exciting security improvements in the exploit defense. So this update, the Windows 10 Creators Update, included multiple security features that were created to make it difficult and costly to find and exploit any software and software vulnerabilities in the Windows 10 operating systems. These features were designed to basically, let me just bring up my pen, were designed to eliminate entire classes of vulnerabilities, to break exploitation techniques, to contain the damage and prevent persistence, and to limit the window of opportunity for an exploit to be successful on the Windows 10 operating system. Now, again, in the following topics and lessons, we'll discuss more and in more detail about the security mitigations in Windows 10 following the creators update up until now. Now, you will also find a link in the downloadable resources for this lesson in the documentation file, which basically discusses content that discusses the features in Windows 10 going from the 1703 update up until now. Okay, so that being said, let's dive into our second topic here and discuss about Windows Hello. And of course, solving the credential problem. So Windows Hello is part of the current Windows 10 release. Windows Hello for Business, formerly known as Microsoft Passport for Work, was also introduced. So the security features for both will be covered in this lesson. First of all, let's talk about solving the credential problems. So a fundamental assumption about information security is that a system can identify who is using it, right? Identifying a user allows the system to decide whether the user is identified appropriately, a process known as authentication, and then decide what a properly authenticated user should be able to do on that system. And this is the process known as authorization, right? The overwhelming majority of computer systems deployed throughout the world depend on user credentials for making authentication and authorization decisions, which means that these systems depend on reusable user-created passwords as the basis for their security. The oft-cited, let's say, maxim that authentication can involve something you know, something you have, or something you are, neatly highlights the issue. A reusable password is an authentication factor all by itself, so anyone who knows that password can impersonate the user who actually owns that password. Over time, the state-of-the-art for password storage and use has advanced, let's say, somewhat with secure hashing and salting, for example, of passwords, but we are still faced with two problems. Passwords are easily cloned, so are very easy to clone, and they are easy to steal. In addition, implementation faults may render them insecure, and users have a hard time balancing convenience and security. Now, the security issues with the passwords that are now facing, in summary, they can be stolen, replayed, even with multiple timestamps in the credential process, and they can be reused on other systems. So these are some problems with passwords. Solving the problems that passwords pose is kind of tricky. Tightening password policies alone will not do it, because users may just recycle, share, or write down passwords, right? Although user education is a critical step for authentication security, education alone does not eliminate the problem either. So Windows Hello is the biometric system built into Windows operating system. It is part of the end user's authentication experience. So formerly Microsoft Passport is a two-factor authentication system that combines some PIN or biometrics like Windows Hello with encrypted keys from a user's device to provide two-factor authentication. The PIN is a fail-safe option, let's say, in case of damage to the biometric reader device. Microsoft Passport takes the PIN or biometric information from Windows Hello, if available, of course, and uses this information to have a TPM chip generate a set of public-private key pairs. The PIN in question is safer than an ordinary PIN or password because it only works with a specific device. Also, the PIN can be of variable length, right? And may have additional requirements regarding length and complexity in businesses. The private key remains secured by the Trusted Platform Module chip, by the TPM chip, and it cannot be accessed directly, but can be used for authentication purposes through the Microsoft Passport API. The public key is used with authentication requests to validate users and to verify the origin of the message. Now, Windows Hello provides a secure authentication experience through either fingerprint scan, iris scan, or infrared facial recognition technology in conjunction with Microsoft Passport. Again, for a very deep dive into the analytics and biometrics in Windows 10, please see the link from the documentation file as downloadable resource for this lesson called Introduction to Windows Hello by Peter Daund on Microsoft Virtual Academy. These links take you to the Microsoft Virtual Academy for a deep dive into this. And we are going to talk next here about authentication. So when a user wants to access protected key material, the authentication process begins with the user entering a PIN or a biometric gesture to unlock the device, a process sometimes called releasing the key. Now, an application can never use the keys from another application, nor can someone ever use the keys from another user. These keys are used to sign in requests that are sent to the identity provider or shortly the IDP seeking access to a specified resource. Applications can use specific APIs to request operations that require key material for actions. Access through these APIs does require explicit validation through a user gesture, and the key material is not exposed to the requesting application. Rather, the application asks for a specific action, like signing a piece of data, and then Windows Hello layer handles the actual work and returns the result. So as you can see, the private key is never exposed. Now, let's have a look at a summary of Windows Hello, let's say, right? So Windows Hello provides, again, a biometric sign-in system that recognizes the user and actively defeats efforts to circumvent proper identification. Individuals can create a PIN or a biometric gesture on their personal devices for convenient sign-in. This use of Windows Hello is unique to the device on which it is set up. However, it is not backed by asymmetric or certificate-based authentication. Now, you will find additional information in regards to this in the downloadable resources for this lesson, like the implementation details for Windows Hello or Windows Hello code sample on GitHub. So please check the documentation file. When Windows 10 first shipped, it included Microsoft Passport and Windows Hello, which basically worked together to provide multi-factor authentication. To simplify deployment and improve supportability, Microsoft has combined these two technologies into one single solution under the Windows Hello name. Now, customers who have already deployed these technologies will not experience any change in the functionality, but customers who have yet to evaluate Windows Hello, they will find it easier to deploy it due to the simplified policies, documentation, and semantics. Now, Windows Hello for Business is the next step in the evolving of user authentication. So Windows Hello for Business lets users authenticate to a Microsoft account, an Active Directory account, a Microsoft Azure Active Directory account, or an identity provider services or a relying party services that supports the FIDO version 2 authentication mechanism. And you will find a link with details to the FIDO, the Fast ID online authentication protocol, in the downloadable resources for this lesson. So, after an initial two-step verification of the user during enrollment, Windows Hello is set up on the user's device, and Windows asks the user to set a gesture, which can be a PIN, a biometric, or a fingerprint. The user provides the gesture to verify their identity. Windows then uses Windows Hello to authenticate the users. It's that simple. Now, as an administrator in an enterprise or educational environment, you can create policies to manage Windows Hello for Business use on Windows 10 based devices that, of course, connect to your organization. Now, the update to Windows Hello for Business. So Windows Hello for Business, which is configured by group policy or mobile device management, uses key-based or certificate-based authentication. This is the first notable thing. Then the identity provider, such as Active Directory, Domain Services, Azure AD, or a Microsoft account, validates user identity and maps the Windows Hello public key to a user account during the registration step. Then the private key never leaves a device when using TPM. So the authenticating server has a public key that is mapped to the user account during the registration process. A personal Microsoft account and corporate Active Directory or Azure Active Directory accounts use a single container for keys. So all keys are separated by identity provider domains to help ensure the user privacy. And then, last but not least, certificate private keys can be protected by the Windows Hello container and the Windows Hello gesture. So now we've kept mentioning the PIN. So why is a PIN better than a password? Well, passwords are basically shared secrets, right? So they are entered on a device and transmitted over the network to a server. An intercepted account name and the password can be used by literally anyone. Because they are not stored on the server, a server breach can reveal all those stored credentials. In Windows 10, Windows Hello replaces passwords. So when the identity provider supports keys, the Windows Hello provisioning process creates a cryptographic key pair to bound the TPM chip from that device, and if the device has a TPM or if the device has a software TPM, right? Access to those keys and obtaining a signature to validate user possession of the private key is enabled only by the PIN or biometric gesture. So the PIN feature is turned off by default in Windows version 1703, and it can be enabled through GPO. Now, this two-step verification that takes place during Windows Hello enrollment creates a trusted relationship between the identity provider and the user when the public portion of the public-private key pair is sent to an identity provider and associated with a user account. When a user enters the gesture on the device, the identity provider knows from the combination of hello keys and gesture that this is verified identity and provides an authentication token that allows Windows 10 to access resources and services. Now, you have a visual representation over here on the slide. Now, imagine that someone was looking over your shoulder as you get money from an ATM and sees the PIN that you enter. Now, having the PIN won't help them access your account because they don't have your ATM card, right? In the same way, learning your PIN for your device doesn't allow the attacker to access your account because the PIN is local to your specific device and doesn't enable any type of authentication from another device. Windows Hello helps protect user identities and their credentials. Because the user doesn't enter a password, except during the provisioning step, sorry, it helps circumvent phishing and brute force attacks. It also helps prevent server breaches because Windows Hello credentials are an asymmetric key pair which helps prevent replay attacks when these key pairs are protected by the TPMs. Now, let's quickly talk about managing Windows Hello for Business. So you can create a group policy or mobile device management policy that will implement Windows Hello for Business on devices running Windows 10. To review the Hello management options, please see the group policy settings for Windows Hello for Business and mobile device management policy settings for Windows Hello for Business from an article in the downloadable resources for this lesson, which I've left you in the documentation file. Now, again, these are the two options to manage Windows Hello for Business, so either group policy or MDM policy. But now let's quickly have a word on the deployment options of Windows Hello for Business. So you have these deployment options. So you have cloud-only deployments, hybrid deployments where you have an environment with an on-premise Active Directory and an Azure Cloud or Microsoft 365 tenant, and of course purely on-premise deployments where your environment is hosted only on premises. Again, these are the three deployment options. You'll find a link called Windows Hello for Business in the downloadable resources, which take you into much more details about each of these three deployment options. So as a summary here, Windows Hello basically represents the biometric framework provided in Windows 10 and enables users to use biometric to sign into their devices by securely storing their username and passwords and releasing it for authentication when the user successfully identifies themselves using biometrics. Windows Hello for Business uses asymmetric key pairs protected by the device's security module that requires a user gesture, of course, that being a PIN or biometrics to authenticate. So that being said, guys, this concludes our discussion on this particular lesson. Of course, I will see everyone in the next lesson where we'll discuss about additional Windows 10 security features and capabilities. So I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional track, Windows 10 Security Features. We are in section 6 of the course, and in this second lesson we are going to discuss about other security features and capabilities. And more specifically, we are going to talk about enterprise certificate pinning, about new group policy settings reference for Windows and Windows Server, Windows Defender Security Center, Windows Defender Exploit Guard, and Windows Defender Application Guard. So that being said, let's hop on to our first topic here and talk about the enterprise certificate pinning. So, released back with the Windows 10 Creators Update, it introduced enterprise certificate pinning that basically enabled IT professionals to create their own key pinning rules for their internal enterprise domain names. So with this technology, you can basically create and deploy pinning rules for your internal Active Directory domain names. So secure HTTP communication to internal endpoints is blocked if there is a perceived man-in-the-middle attack. With enterprise certificate pinning, you can pin or associate, let's say, an X.509 certificate and its public key to its certification authority, either to the root or the leaf certification authority. Windows certificate APIs, that is Cert Verify Certificate Chain Policy and Win Verify Trust, are updated to check if the site's server authentication certificate chain matches a restricted set of certificates. These restrictions are encapsulated in a PIN rules certificate trust list, that is shortly called CTL, that is configured and deployed to Windows 10 computers. Any site certificate triggering a name mismatch causes Windows to write an event to the CAPI2 event log and prevents the user from navigating to the website using Microsoft Edge or Internet Explorer. External domain names, where the certificate issued to these domains is issued by a public certificate authority, are not ideal for enterprise certificate pinning. Web administrators should configure their web servers to use HTTP public key pinning, so that is HPKP, and encourage users to use web browsers that support HPKP. Now, for detailed information about enterprise certificate pinning and deployment details, please see the links in the documentation file I left you as downloadable resources for this particular lesson. That being said, let's hop on to our next topic and talk about the new group policy settings reference for Windows and Windows Server. The new GPO settings are detailed basically in a spreadsheet. All the details you will find in a spreadsheet, for which I left you a link in the downloadable resources. These spreadsheets list the policy settings for computer and user configuration that are included in the administrative template files delivered with the Windows 10 operating system specified. So you can configure these policy settings when you edit group policy objects. The administrative template spreadsheet contains 3 columns that provide more information about each policy settings behavior related to reboots, logoffs, and schema extensions. Now, these columns are the following. So, reboot required. A yes in this column means that the Windows operating system requires a restart before it applies the described policy setting. Then you have the log off required column, and a yes in this column means that the Windows operating system requires the user to log off and log on again before it applies the described policy setting. Then you have Active Directory schema or domain requirements, and a yes in this column means that you must extend the Active Directory schema before you can deploy the policy setting. And status and a new in this column means that the setting did not exist prior to Windows Server 2012 R2 and Windows 8.1. It does not mean that the setting applies only to Windows Server 2012 R2 and Windows 8.1. Now, you can refer to the column entitled Supported On to determine which operating system the policy setting applies to. So, please download the spreadsheets, take a look through them, because you'll find detailed information in regards to this. And that being said, we are going to go to our next topic here and talk about the Windows Defender Security Center. So again, released back in Windows 10 Creators Update, Windows Defender Security Center was introduced, shortly called WDSC, to make it easier to view and control the security protections you choose and better understand the security features already protecting Windows 10 devices. So the Windows Defender Security Center app can be accessed by either opening Windows Defender Security Center, clicking on Start Story and searching for Windows Defender Security Center, and then you will have many settings that were previously part of the individual features, and main Windows settings have been combined and moved to the new app, which is installed out of the box as part of Windows 10. Now, the app includes virus and many sections but in fact, let me just show you. I'm just going to open up Windows Defender Security Center. So let me click on Start. You won't see this because it's on my other screen, but this is it. So it includes virus and threat protection, and here you can see settings for Windows Defender Antivirus and all the settings for it. You can see them over here. You can navigate through them. You can go through them. Then back in the main page over here, you have device performance and health. This is the one over here, which basically includes information about drivers, storage space, and general Windows Update issues. Then getting back again to the main page, you will also have firewall and network protection. Here it is. This also includes Windows Firewall. You can see the domain networks over here. You can firewall notification settings. You can go to advanced settings where you would create or amend rules in your firewall and so on. Then you will have app and browser control over here. And this is basically covering Windows Defender Smart Screen settings for Internet Explorer and Microsoft Edge. Also, a review of the built-in exploit protection setting for the system and programs, as well as the capability to customize them. So actually, you can customize everything from within app and browser control over here. And then you have as well family options, which include a number of parental controls, along with tips and information for keeping kids safe online, right? So let me close this down. And basically, the Windows Defender Security Center uses the Windows Security Center service to provide the status and information on non-Microsoft antivirus and firewall products that may be installed on the device. Now, again, in the virus and threat protection, if I just open this up again very quickly, because it's better if I just show you. So if I go into browser virus and threat protection over here, Windows Defender Security Center basically provides the virus and threat protection area to help you scan for threats on your device. You can also get updates to the latest protection offered by Windows Defender Antivirus and also see the results of your previous scans. So these are, again, here you can see the current threats, the number of files scanned, the last scan duration. You can see the history of threats. Again, let me get back over here, and more and more and more. Settings configured with management tools such as Group Policy, Microsoft Intune, or System Center Configuration Manager will generally take precedence over the settings in the Windows Defender Security Center. I mean, if this was a corporate device and these settings were configured through Group Policy, for example, probably you would not be able to change the settings here, the settings that were configured through Group Policy. Now, the Windows Defender Security Center, and now indeed, let me close this, is a client interface on Windows 10, and it is not the Windows Defender Security Center web portal that is used by Microsoft Defender for endpoints. Okay, you will also have links with information in regards to Windows Defender Security Center features in the downloadable resources for this particular lesson. That being said, let's go ahead and talk about now Windows Defender Exploit Guard. So as listed, as I've mentioned, with Windows 10 Creators Update, you can audit, configure, and manage Windows system and application exploit mitigations right from the Windows Defender Security Center. You do not need to deploy or install Windows Defender Antivirus or any other additional software to take advantage of these settings, and Windows Defender Exploit Guard will be available on every Windows 10 PC running, of course, the full Creators Update or later. So, first of all, if you want to see the settings for Exploit Guard, of course, let me again open up the Security Center over here. You would go to App and Browser Control, and then you will search for Exploit Protection Settings. These are over here. And here you can see that you have lots and lots of settings, system settings and program settings that you can configure. And of course, with Exploit Guard Enterprise, you can help secure legacy apps that were not compiled with Control Flow Guard CFG enabled. And this legacy apps control flow protection would include export address filtering, import address filtering, validate API invocation, simulate execution, and validate stack integrity. Now, in terms of upcoming features, Windows Defender Exploit Guard will be fully integrated with Microsoft and is at some extent integrated with Microsoft Defender for Endpoint, formerly known as Microsoft Defender ATP. Okay, let me close it down and get on to our next topic over here and talk about the Windows Defender Application Guard. Again, you'll find links to Windows Defender Exploit Guard, more details and additional reading in the downloadable resources for this lesson. So, Application Guard. Isolating threats from, let's say, the most vulnerable surface areas is what Application Guard does. So one of the most common targets for attackers would be often your browser, right? With more than 90% of attacks using hyperlinks to initiate stealing credentials, installing malware, or exploiting vulnerabilities. Now, designed for Windows 10 and Microsoft Edge, Windows Defender Application Guard, or shortly called WDAG, helps to isolate enterprise-defined untrusted sites, protecting your company while your employees browse the internet. As an enterprise administrator, you can define what is among trusted websites, cloud resources, and internal networks. Everything not on your list will be considered untrusted. So, if an employee goes to an untrusted site through either Microsoft Edge or Internet Explorer, Microsoft Edge opens that site in an isolated Hyper-V enabled container, which is separate from the host operating system. This container isolation means that if the untrusted site turns out to be malicious, the host PC is protected and the attacker can't get to your enterprise data. For example, this approach makes the isolated container anonymous, so the attacker can't get to your employees' enterprise credentials, for example, right? Okay, sorry. So, Application Guard is, let me just change the slide over here. Application Guard has been created to target three types of enterprise systems. That is, enterprise desktops. So these desktops are usually domain joined and managed by your organization. Configuration management is primarily done through System Center Configuration Manager or Microsoft Intune. Employees typically have standard user privilege and use high bandwidth wired corporate network. Then, the other types of system for which Application Guard was created would be the enterprise mobile laptops. Now, these laptops are also domain joined and managed by your organization. Again, configuration management is primarily done through SCCM or Microsoft Intune, and employees typically have standard user privileges and use high bandwidth wireless corporate network. And then, for devices of type bring your own device, BYOD. These are personally owned laptops that are not domain joined but are managed by your organization through tools like Microsoft Intune. The employee is typically an admin on this device and uses a high bandwidth wireless corporate network while at work and a comparable personal network while at home. So just as a summary here now, Windows Defender Application Guard, as you can see here at the bottom of the page, I also put this in writing, is designed to stop attackers from establishing a foothold on the local machine or from expanding out into the rest of the corporate network. If someone accidentally downloads malicious malware from their browser, or if a zero-day exploit is encountered, Windows Defender Application Guard isolates and contains the threat, securing your devices, apps, data, and network. Now, further than this, more than this, Microsoft Defender for Endpoint, formerly called Microsoft Defender Advanced Threat Protection, will provide optics and detection and response, so your SecOps teams will have full visibility to any threats that have been encountered. With Windows Defender Application Guard and Windows Defender Exploit Guard, you have an extra layer of defense against malware attacks in between the firewall and your antivirus software. So that being said, this concludes our discussion for this particular lesson. And of course, I will see everyone in the next lesson where we'll actually discuss about an actual ransomware case study. So I'll see everyone in the next lesson. And of course, I hope this has been informative for you, and thank you for viewing. Hello everyone, and welcome back to this course from the Microsoft Cybersecurity Professional Track, Windows 10 Security Features. We are in section 6, and this is the last lesson of the course, in which I thought it would be useful to talk about an actual ransomware case study. So we're going to talk about some ransomware protection, and then about the case study Windows 10 Platform Resilience against the Petya ransomware attack. Now, first of all, over the last few years, ransomware has rapidly evolved into one of the most lucrative revenue channels for cybercriminals. Reports estimate that ransomware operators earned somewhere around $1 billion back in 2016 from ransom paid by victims. Ransomware's low-risk, high-reward method of illegally extorting money comes from the perpetrator's ability to hide behind various command and control servers, run nearly untraceable transactions using cryptocurrency such as Bitcoin. And then we have the last item on our list over here, and that is ransomware as a service. This one, right? And ransomware as a service, which is a cybercriminal business model that makes the latest versions of ransomware available in the underground marketplace and accounts for a significant portion of ransomware and related Trojan downloaders, whose volume were peaking over the last few years. So we have observed a downward trend towards the end of 2016, but the number of ransomware in the wild started to pick up again in 2017, and it is still going on. Now, ransomware operators, so let me just change the slide over here, have explained basically their delivery options to target computers. And these are the browser delivery option, right? Historically, ransomware operations heavily used exploit kits which take advantage of browser vulnerabilities to download malware on vulnerable computers. However, there's been a sizable decline in the use of drive-by downloads to install ransomware on computers. Then you have the email delivery method, and the staple distribution channel continues to be the email, of course. Socially engineered emails carry Trojan downloaders that install ransomware payloads, and unfortunately, email distribution continues to prove effective in malware campaigns, even in our days. You'll have a link, of course, in the downloadable resources, which takes you to an article that is the Verizon's data breach investigation report for the year of 2016 and the other years, that actually shows that if an attacker sends an email to 100 people in one company, 30 people will open the email and 12 people will open the attachment or click on the link within the email. Then you have the network delivery method, and here network propagation is not a typical ransomware behavior. However, new ransomware families like Spora, for example, the modified version of Spora, have the capability to spread via mapped network drives and removable drives. So there's also been observations of new ransomware campaign that start to use the remote desktop protocol to propagate. Now, the other one would be server message block, and that is SMB. And SMB vulnerability to spread rapidly to out-of-date machines within a short span of time. We saw that with WannaCrypt's use of an exploit that gave it the ability to attain critical mass, impacting many out-of-the-date computers. Now, active criminal operations show that the threat of ransomware continues to evolve. Campaigns attempt to go unnoticed by operating an average of 7 hours, just enough time for victims to pay the ransom, right? In addition, ransomware threats are increasingly more polymorphic and don't stop coming up with inventive ways to bypass both static and dynamic antivirus detections. Now, let me just change the slide over here. You have a representation, an illustration of what I've just said here over in the slide, so please take a look. So the latest update on the state ransomware you will find in a link which I've left in the downloadable resources for this lesson. Now, the following case study shows how the layered security services of Windows 10 help mitigate the Petya ransomware attack. So let's get right into it and talk about the case study. So let me change the slide over here. Now, the following is basically an excerpt of from the Windows Security, the new Microsoft Protection Center blog. To read detailed and fascinating forensics analysis of the Petya ransomware attack, you will find two links in the downloadable resources for this lesson. One of them called New Ransomware, Old Techniques, Petya Adds Worm Capabilities, and the other one is called Windows 10 Platform Resilience Against the Petya Ransomware Attack. Now, on June 27, 2017, reports of a ransomware infection began spreading across Europe. We saw the first infections in Ukraine, so the attack started in Ukraine, right? Where more than 12,500 machines encountered the threat. Then it was observed that infections started in other 64 countries or regions, including Belgium, Brazil, Germany, Russia, and the United States. Now, the new ransomware has worm capabilities, which basically allows it to move laterally across infected networks. Based on Microsoft's investigation, this ransomware shares similar codes and is a new variant of ransom Win32/Petya. Again, you'll find links to detailed information in regards to this in the downloadable resources. And the new strain of ransomware, however, was more sophisticated. However, the telemetry shows a less widespread attack. So the new Petya variant was highly sophisticated malware, but the telemetry shows that it had far less reach than expected. Like given the fact that it had worm-like spreading capabilities. The attack, of course, started in Ukraine when the dust settled. More than 70% of the machines that encountered Petya were in Ukraine. Now, it managed to spread to machines in other countries as well, or regions, but in significantly lower volumes. And the majority of the infections observed were on Windows 7 machines. Now, to protect their customers, Microsoft released cloud-delivered protection updates and made updates to their signature definition package shortly after. These updates were automatically delivered to all Microsoft free anti-malware products, including Windows Defender Antivirus and Microsoft Security Essentials back at that time. Windows Defender Advanced Threat Protection, Microsoft Defender Advanced Threat Protection, now called Microsoft Defender for Endpoint, automatically detects behaviors used by this ransomware variant without any updates. Now, let's talk about the Windows 10 protection and mitigation. Now, the Petya ransomware combines multiple well-known techniques for propagation and infection that are not new to the security researchers. The noteworthy aspect is that Petya's developers took techniques normally used by penetration testers and hackers and built a sophisticated multi-threaded automation of these techniques inside a single piece of code. Such attacker techniques are part of the modern threat landscape and are continuously researched by security teams at Microsoft, resulting in new mitigations, hardening, or defensive measures are then integrated into Microsoft products and operating systems, of course. Now, Windows 10 follows this philosophy of continuous mitigation improvements. From Microsoft's analysis of PETIA, they could measure the defenses provided by Windows 10. Summarized in the diagram here on the slide, you have how mitigations and security features can help disrupt the different stages of this attack. So please take a look and take a look at the diagram and go through the attack chain, right? So PETIA's kill chain diagram with platform defenses able to mitigate or prevent certain techniques in Windows 10. Each mitigation in this diagram is placed on top of the specific malware techniques. So this is the malicious software download. This is the mitigation in Windows 10 stack. Okay, which are either fully prevented or mitigated in Windows 10. For an overview and specific details of these mitigations included in Windows 10, please see sections 1 through 3, which we have covered in this course. Now, first of all, you have Device Guard over here. And Device Guard can enforce strong code integrity policies to allow only trusted signed apps to run. It can thus block the entry vector of PETIA, which is basically an updater running an untrusted binary, and also the further propagation attempts executing untrusted DLLs either through PCXAC or WMI. Okay, then you have the Credential Guard over here, right? And this uses virtualization-based security to isolate the LS-ASS process, so it fully protects from credential dump executed by PETIA using the external Mimikatz-like tool. It also protects the domain credentials stored in the Windows Credential Store. Access tokens exposed in memory can still be leveraged by PETIA, but this is a less effective propagation mechanism, and it relies on third-party tools and other processes active in memory while PETIA executes. Now, several exploits mitigations such as better randomization of the kernel or NX hole or page pool are included by default in Windows 10, and they help mitigate the SMB exploits like Eternal Blue or Eternal Romance. More mitigations like control flow guard for kernel or kernel code integrity are automatically enabled with Device Guard to provide additional resistance also to new exploits. Then we have the UEFI and the secured boot over here, right? And UEFI Secure Boot is the security standard that uses hardware features to protect boot processes and firmware against tampering. Now, this protection will stop the dangerous disk encryption executed by PETIA with a bootloader. After PETIA's forced reboot, a machine with Secure Boot will detect the anomalous bootloader and prevent further execution, containing the damage and preventing the very dangerous encryption of disk sectors, leading to a complete loss of data. A machine in this state will be prevented from booting and can be recovered with regular repair functionality from the Windows 10 USB or DVD media. One note here is that individual files encrypted by PETIA in the limited time before reboot will remain encrypted and must be recovered from backup copies. Then you have AppLocker, and this is the one over here. And AppLocker can also be used to block execution of certain programs like PCXAC or unsigned binaries like PETIA's DLL library for machines that cannot benefit from Device Guard due to the lack of the specific hardware requirements or due to older operating systems not supporting new mitigations. So again, you can leverage UpLocker for this. Now, finally, administrators of networks with older operating systems like Windows 7, which, by the way, is no longer in support, but trust me, there are lots and lots and lots of Windows 7 machines out there. So, with operating systems like Windows 7, which do not benefit of modern hardware and software mitigations, may consider deploying some hardened configurations that could help to slow down or remove certain lateral movement techniques. Such hardened configurations may impact legitimate functionality such as file sharing or remote management, and so it needs to be evaluated carefully before deployment. Now you can think of blocking or restricting access to specific IPs for file sharing services like SMB. You can block remote execution through PCXec, and you can use access control lists, remote WMI access. And you'll have links for this in the downloadable resources for this lesson. Now, this petty outbreaks exemplifies the ever-increasing sophistication of ransomware attacks. A multi-layer defense stack is needed to protect computers and networks. And of course, at Microsoft, they strive to continuously enhance Windows 10 with next generation features to protect customers, as described here in the diagram below. And here you have a slide which goes through everything that I've just went through, secure boot, app locker, but I wanted to keep it on this slide to show you exactly, while I was talking about this mitigations and defense stack, to show you exactly on the diagram so you can see the actions taken by Petya and their mitigations from the from the Windows 10 security stack. Now, again, these are the three things that I've just mentioned, which can be done by administrators of networks with older operating systems like Windows 7. Now, that being said, guys, let's wrap it up with a summary, and let's say that security threats are some of the leading concerns that everyone has with technology today, and that's why Windows 10 was built to be the most secure version of Windows ever. So with comprehensive built-in security features, Windows 10 provides protection from viruses, malware threats, including ransomware, provides safer authentication with Windows Hello, using your face or fingerprint to log in, and provides ongoing security updates delivered monthly through the Windows Update service. Now, this basically concludes the discussion on our lesson, and it concludes the discussion on this course as well. Please go ahead and do the review questions for each section. Please go ahead and do the final exam questions. And very important, and I strongly recommend, go ahead and do the labs for the course, because you'll have 5 labs available for this course, in which you'll get to to implement hands-on, to play with the technologies that we've just discussed throughout the course, like App Locker, Device Guard, and so on. I hope you enjoyed the course. I hope you found lots of useful information and you learned lots of new things and useful things. And again, for the last time in this course, I hope this has been informative for you, and thank you for viewing.